Okay, very good morning, everyone. My name is Sam, the co-chair of Global Young Academy.
And I'm Yancy.
Yeah, it is our pleasure to welcome you to the International Conference of Young Scientists here in Bremen. Thank you all for being here, both of those who have traveled across the globe and those joining online. Wherever you are, it is your presence spanning from many countries, backgrounds that give this conference hopes and possibilities. We are very deeply grateful to Constructor University for hosting the conference and to our funder and sponsor, the International Academic Partnership, the City of Bremen, Gordon and Betty Moore Foundations, Krups Foundations, DFG, Elsevier, DAAD, of course, Springer Nature, Inside Europe, and as well as European Academy Science Advisory Council. Thank you very much. Thank you for your support that make this meeting possible. Thank you.
So, excuse me. This year, our theme is machine learning. And we have chosen it because there's no other field advancing so much and being so disruptive scientifically and technologically, and also for society. And few fields like this demand a lot from us young scientists. Machine learning is already rewriting how we do climate science, medicine, agriculture, even how we do research itself. But the hardest questions it raises are not only technical, they are about evidence, about fairness, and about human rights, and about who gets a say. There are questions a Global Young Academy is uniquely placed to take on. Just as the Secretary General of the United Nations said on his message to us, we will display it now. Breakthroughs happen through connection across disciplines and across borders. I encourage you to use the time to exchange ideas, challenge assumptions, and build new collaborations. Our future depends on scientists who place the planet and people at the heart of all they do. The new generation of thinkers is in this room. May your eureka moments shape a better world for all of us. The new generation of thinkers, that is us here. So let us use these days exactly as he described. Exchange ideas, challenge each other's assumptions, and leave Bremen with collaborations that didn't exist when we arrived. Welcome to Bremen and welcome to this conference. Let's get us started.
So next, I would like to honorably invite Professor Devi S. Rosenblum, the Vice President for Research, Constructor University of Bremen, for your opening remarks.
Good morning, everyone. My name is David Rosenblum, and I'm the Vice President for Research here at Constructor University. And on behalf of the university and all of us in the broader Constructor group, it's my sincere pleasure to welcome you to Bremen for this 2026 Global Young Academy Conference. The theme of the conference is, I saw it there, yes, machine intelligence for society and all sciences. Society and all sciences. That pretty much covers everything, doesn't it? And it's appropriate that it should cover everything because AI technology, and particularly generative AI, is completely transforming the human experience. It's transforming the way that we work. It's transforming the way we learn and the way we teach. It's transforming the way we interact with one another. And it's transforming the way we think, at least to the extent that we're still doing our own thinking now. But a major implication of these transformations, is that we're experiencing a strong discontinuity between the older generation of scientists and academics like myself, who've brought us to this point in time, and the newer generation represented by many of you in this room. This discontinuity is something that I live every day. So I'm a computer scientist. And for instance, in computer science, we've built up at least 6 decades of experience in teaching students how to program a computer. But thanks to the impact of generative AI and agentic software development, a lot of that experience and expertise is rapidly becoming obsolete and irrelevant. So what this means then is that the young generation of scientists have the opportunity to shape our AI-dominated future in a way that's free of the legacy thinking and cognitive biases that guide those of us in the older generation. And I really envy you for that. It'd be nice to be starting my career all over again in this brave new world. So during your time at the university this week, I encourage you to reflect on the great opportunity and great responsibility that await you as you embark on shaping the future role of AI in society and all sciences. And with that, I would like to wish all of you a very productive meeting this week. And I hope you manage to find time to explore our nice university and enjoy the nice weather that we're experiencing this week. And I hope you have a very pleasant stay here in Bremen as well. So thank you.
Now it's my great privilege to introduce an esteemed colleague who I admire a lot, Robert Dijkgraaf, who is a theoretical physicist who has led the Institute of Advanced Study and served as the Netherlands Minister of Education. In this next October, he will become president, now he's president-elect, of the International Science Council. Beyond science, few scientists have done more for those at the start of their careers. So Robert has encouraged the foundations of young academies, built the grants and posts that will let young researchers stand on their own. And for many of us, he's a proof that rigor and public purpose belong together. Welcome, Robert.
Good morning, and wonderful to be with you, and thank you for that lovely introduction. And I was thinking perhaps I'm one of the few people here who actually attended the very first meeting of the Global Young Academy. It was, I think, in China, 2010 or something. You remember, very good. Anyhow, I think it's wonderful to see you here, and that this movement, which it is being so successful. So a few words to put perhaps also these lovely days here in Bremen in a context. And I want to start with a little anecdote. It's an anecdote told of Leonid Brezhnev. He was once asked whether he could say what the state of the Soviet Union was in one word, and his answer was good. And then he was asked, what if you could use 2 words? And the answer was not good. And that is actually the state of science. And I'll be honest, I think, we're living in an amazing time. I think actually, honestly, I totally agree with you. What a privilege to be a young scientist right now, because we see unprecedented opportunities in terms of the tools, the techniques, the technologies. I like to put it as follows, like the 20th century was about discovering the building blocks of reality. The 21st century is about actually building and designing. And you're at the start of that. So we know the building blocks of life, genes, molecules, cells, of matter in terms of particles and atoms, and of information, the bits, and There's a beautiful story how these were discovered. But now we are in a time of genetic editing, artificial life, quantum and nanomaterials, and of course, AI, neural nets. And in fact, it means that I always thought, what do scientists do? Scientists are like these old, explorers. They had a map of the world, and only a small part of the world was known. It was about finding those unknown parts of nature. But now I think we are in a very different part, because nature itself is only a very, very small part of everything we can build and design. So the organisms you found in nature, the materials you find in nature, the thoughts that we have found in nature, they're only a part of what can be explored. So you're basically, previous generations were on this narrow, winding river, and you are going into the full ocean. And in fact, all these developments are accelerating. And I love the fact that you have taken the topic of AI central, because it's both creating this great potential, the good, and raising also deep questions, the not good. And one way I see this is, so my own field is particle physics and cosmology. So I do the easy stuff, Small particles, few lines, describes the standard model of elementary particles. And general relativity is even a shorter line. But we are now endeavoring in what I call the muddy, messy middle, all those areas of great complexity. And I think here exactly where AI showed great promise, whether it's the climate, whether it's the oceans, new materials, human behavior. Okay, and then on top of that, we have a worldwide pool of talent, and we have technology that makes us work like a collective. If you just see at this little graph where you see the rise of scientific publications in the past 10 years, you see whole parts of the world literally coming online. And this map, it's not from your in-flight magazine, but it shows the connectivity of the scientific community. So I think that's an absolutely amazing fact. So this shows the collaborations of all different journal articles and how they are spread around the world. So that's the good. And then, of course, all of that science I've experienced myself is being applied in lots of policy domains, and all the global challenges actually need the impact of science, and the UN Secretary General put it really well. But we are also living in challenging times. So let me indicate a few of those pressures. Clearly, academic freedom is squeezed around the world. It's might be ideological, it might be financial, but the free space for inquiry is not expanding. We see disinformation ranging around the world, often disguised like fake science, very, very believable. We see governments increasingly looking at science through an economic lens. So they want short-term, immediate response. A lot of discoveries being privatized. In the United States, now 80% of all the research and development is in private hands. Only 20% is still public. The humanities and the social sciences are increasingly marginalized. They're seen not as part of this economic model, and while they are absolutely essential to answer the questions how we actually absorb those technologies. And finally, I think we see the thing called the securitization or weaponization of science, increasing emphasis on national security. And that means that international collaboration is seen as much more as a threat than as an opportunity. And so I think all these developments will stay with us, and we have to navigate them. And in fact, lovely to hear the UN Secretary General. I sometimes introduce the International Science Council, say, well, it's something like the UN of science. And then people look at me and say, well, I hope not. And that actually is in one line the summary where we are as an international scientific community, right? The UN and other its agencies, in fact, diplomacy itself is being weakened, it's being undercut. Those institutions that are here to safeguard the planet are threatened. The SDGs and technology regulation is seen as a threat for industrial expansion. In fact, we are seen as being part of world government and a threat in that way. And in fact, it's wonderful to see this kind of people coming from all corners of the world. But in many parts of the world, particularly in the global south, I think people are losing faith Is there truth in advertising? Is science actually delivering on its promises? Can we actually solve those issues? And why is this all happening? So let me just mention a few of things. Well, first, I think in some sense our success. I joke it's the social equivalent of Newton's third law. Action is reaction. Science pushes society, and society pushes back. There are messages about climate change, about technology that are not welcome in certain corners. We see a widening interface. Science and policy are more entangled. We have a more important role to play in a lot of political issues, and that creates friction. So COVID, which I thought was really like the Sputnik moment of this generation, led also to accelerate a lot of the distrust in society. And then I think something I really worry about, there are lots of fault lines in society, but increasingly they are along educational lines. So if we move to a world that only those who attended universities appreciate universities and research, that actually is a really worrying development. And we see this in many parts of the world. And overlaying, I would say, there's this post-war social compact, where societies had decided to spend massively in science because it will be at the benefit of all. It's a global commons. It's a global public good. And we see that this contract needs some kind of rethinking, to put it mildly. And all of this happening in this strange, impossible triangle of science and society and politics. So I was in politics for a brief time, and when I actually joined the Dutch government, there was this cartoon. I explained that you see me descending from the ivory tower in Princeton into a big black hole which says politics. And actually, this is a truthful presentation, because if you look at the societal appreciation of jobs, trust, scientists are seen still as the most trustworthy group in society, and politicians, government ministers and politicians in general, are at the very bottom, right? So this is part of the tension that we're navigating, because if these two are interacting, you have a very different way. And the way I think of this, the way we are interacting now with science and policy and politics, it used to be that science was quite an enclosed and kind of little island. So there was some interface, but not that big. And there were a few people dedicated that were doing some science advice. Now I think science is almost atomized. It's in every part of our lives. Anything we do, it's in our bloodstream, it's in our pockets, So I think of science more as this fractal that is, everywhere in science. And so the science-society interface is this huge fractal border that needs to be guarded. And I think many of what you will be discussing this week all takes place on this complicated interface. There's this saying, if you mix science with politics, you get politics. I think that's too easy. But there is a real delicate discussion and a knowledge that has to be developed how to treat those two different worlds that have I would tell you from my experience, not a black hole. It has its own laws, not the laws of physics, but there are laws there in the black hole, and you can escape, by the way. So what can we do, particularly to keep science global? So I think one thing I learned from people in social movements is the phrase "pushback against the pushback." So we see pushback from society, from political things, organize ourselves, know this is happening, and kind of line up and do this together. I think that's a very important message. And we have forcefully defend things that we thought were obvious, perhaps, in the past. Particularly, we have to actively create that space for cooperation. We have to avoid this risk-averse sensorial posture. There's a beautiful German word for us, eilende Gehorsamkeit, which means, anticipatory obedience. There is a certain risk that organizations say, well, let's not bother, let's not rock the boat, etc. It's very natural. Perhaps it's smart, but it's not principled. So we have actively pushed our university administrations, our governments, to still promote and exchange scholarship. And we should advocate, we should make clear to policymakers why we need international collaboration. There are two obvious areas: global challenges, obvious, pandemics, the climate doesn't stop at the national borders, and basic research, actually, where obviously it's a win-win situation. And we have to engage the scientific community. I see too many of my colleagues that feel all those issues can be delegated to administrators, to politicians, and I'm afraid this is no longer the case. We are, in some sense, all actively engaged in those topics. And we have to exchange best practices, and that's why it's so good that we are together here, that you are together. Like to joke, the best way to good idea is to steal it from your neighbor, and I hope you do a lot of this. Actually works in science too. So I feel we are in this transitionary period, and I like to quote, it's a little bit of a misquote, Steven Weinberg, who basically said, in science, we typically learn about nature, but sometimes in science, we learn about science. So it's not that we're introspective, but I think actually this is a time when we have to look at the full picture. The scientific enterprise needs an update. And I think we need you. There's this famous phrase, the world has problems, the university has departments. And I have a little corollary to it. The governments have ministries, So it's, I joke, it often happens to me, I take the wrong plug to the wrong socket or something. You all know this if you travel internationally. But there's a disconnect between the demands in society and the way science is organized. We have built a huge, complicated scientific infrastructure. I think we need more experimentation. If you look at the architecture, too many interior walls, the lowered ceilings. We are disconnected from society. I love ivory towers, but I also love marketplaces where you can actually engage with the public. And actually those silos are actually preventing a lot of the interchange that could happen, because many of the issues you will discuss also here and in the future are relevant for all different walks of life of science in every country, in every university, in every field. So we need more horizontal discussions instead of vertical ones. Towers are nice for vertical, horizontal marketplaces. So I feel, there's this wave, and I always tell young scientists, science comes in waves. Surf the wave, don't drown in it. And I think, this is a wonderful opportunity. I think you are in a position not only to do wonderful science, but rebuild and rethink and redesign the scientific enterprise. So here are finally some tips for you. So there are only 6. First, that social compact, what is it? It has to be rewritten. What exactly are we promising to society? What are we doing to society? What can we deliver? And what are we asking from society? And I think nobody knows exactly what it is, but I know some of the ingredients. It's about public engagement. It's about doing science policy and policy for science, being transdisciplinary, work with all stakeholders. I think we know the ingredients of this kind of meal that you need to make. And then, we have to be, people like to say, be inclusive. And then once somebody said to me, stop using the word inclusive, because inclusive is about, do you fit into the enterprise? You should think about expansion. Can we grow big enough so that there's space for everyone? I think, different career paths, different profiles, non-traditional sources of knowledge and tradition. And I like to say not fitting into system should fit into the system. And that actually means that we have to expand. We have to protect this global commons. We often say it's a public good, but somebody said it's more like a commons in the sense, it's like a beautiful garden that is being taken care of by scientists. But we want to invite all of society. And there's this right to participate and to benefit from science as a universal declaration, as part of the Universal Declaration of Human Rights, I think 1948, 49. So countries already agreed to this, but we're not doing this. And then, address those critical challenges. Actually, there should be truth in advertising. We should work on the global challenges. And through worldwide cooperation and sharing our data, our insights, our scholarships, and our talent. And then create this kind of safe science policy interface. I think all of you want to participate in this, but honestly, it's sometimes very threatening to be there. Those who are actually most engaged with relevant policy domains are the ones that are often most under threat and literally, under attack. So we have to somehow create these kind of safe spaces where we can interact with society. And finally, I think, there are our fundamental values. Freedom, openness, transparency. I often get the question, Robert, isn't that naive? Aren't you living in a la-la land, where what is typically, what scientists are being accused of? And I think it's not the case. But I think we want to defend those values while not being naive. And I think that is our big challenge. And not because they are ideological goals, but they are operational ones. We have experienced again and again, by sharing knowledge, by bringing people together, we can do certain things as scientists that, others cannot. I like to say, in terms of geopolitics, politicians, governments, intergovernmental organizations are sitting on the first row of this geopolitical theater. We are sitting in the second ring, which means we can do less, but it also means we can do more. And in the past, we have seen many, many initiatives where in difficult times, scientists led the way by believing and articulating those fundamental values. So my closing line is that kind of geopolitics is too important to leave to politicians. We need scientists and we need young scientists. So good luck to all of you.
Thank you, Professor Robert. So next we will have our panelists on strengthening global research collaboration for science as global public good. I will hand this session over to our moderator, Professor Michael Saliba, which is a globally recognized scientist in photovoltaic and sustainable energy. He is the director of Institute of Photovoltaic at the University of Stuttgart, a distinguished alumnus of GYA, past co-chair of GYA. He has also championed interdisciplinary collaboration, science diplomacy, support for EMCR. His leadership, scientific excellence, and commitment to impactful innovation has earned him international recognition. So the floor is yours, Professor Michael Saliba.
Thank you so much. So that brings us to the panel session. So I'm just moderating it actually. So the show is all of the panelists. So I will ask them one by one to take a seat. First of all, it's Robert Diegraf. We saw him already. There's not much to say. Some distinctions. So he was also the former Minister of Education in the Netherlands and other stuff, all very powerful people and distinguished in the first place. Then the next one is Marilyn Docterom. So she's the co-chair of the Inter-Academy Partnership, and she's also the former president of the Netherlands Academy of Arts and Sciences and at TU Delft. And thirdly, there's Marcelo Knobel, who's at WAS, the World Academy of Science, and he was also director, so that's the president of the University of Campinas in Brazil, the only one who still has a team in the World Cup. Yeah, so that's also important. Of the panelists here, same for Germany. But let's all welcome him here. Well, Brazil, completely unknown team, of course, yeah. And that brings me now to the next panelist, who's Natisha Duki. So she's a former co-chair of the South African Young Academy of Science, and she's in Human Sciences and Research Council in Pretoria as well, and she's a member of the GYA. Natisha. And the next one is Kerstin Pahl, who's a member of the Junge Akademie of Germany and also on the board of ALEA, all European academies. She's at Max Planck Institute and at HU Berlin, historian, humanitarian, and political studies as well. Let's all welcome her. And lastly, this brings us to Abdul Sattar Sultan. He's the president of the Arab German Young Academy. He's also a member of the GYA. He's based in Erbil in Iraq. I saw the Tower of Babel. That's kind of the region where we're talking about. So let's all welcome him as well. So there's not much to say after this great talk that Robert gave us earlier, but maybe we'll start with something in these very testing times where each of you can briefly maybe give an example of what is one scientific collaboration or organization which gives you a lot of hope for the future that you think worked particularly well and where the Global Young Academy can learn a lot from as well. So maybe we go in the order. You have also microphones in front of you. Perhaps just next to me.
Okay, good morning, everyone. It's my pleasure and honor to be with all of you. Thank you so much again to give me this opportunity to be here. My name is Abdul Sattar Sultan. I'm based in Catholic University in Erbil, and also I'm the co-president of the Arab German Academy of Science and Humanities. It's like a wonderful platform since we are working together as the Arab and German members. It's a wonderful bridge also to collaborate together and all the voices are equal. And my experience with them, we are really making the decisions, and I'm so happy also to see our project impact for the society. Thank you.
Geht das? Oh, wunderbar. Sorry. Thank you also from my side for this invitation. It's really great to be a part of this panel. So since I'm representing two institutions here, namely the German Young Academy and ALEA, I'm also going to give two examples from both, because the German Young Academy is very active, one of the probably the most active young academies within the ALEA network. And what gives me hope is actually that the activities align. We had at the Young Academy, we have at the moment a great project that is called Proofing the Academy. That is about how you can actually come up with strategies to make academy more resilient. And this corresponds with similar activities within ALEA, where a very active task force on trust in science is currently working. And what gives me actually hope is that all what you actually outlined are not just abstract units or entities, but they're actively worked upon, on in concrete settings.
Thanks so much.
I think you need to push the button.
Thanks so much. I think for me, thank you so much, Michael, for the question. And I think when Prof. Robert spoke about securitization of science and visa curves, I was almost jumping in my seat in silence. And I think why? Because of the relationship between the GYA and the IAC. We realized as we conversed over the last year that we were wanting to, initiate a similar project around visa mobility, researcher mobility. And so now we can finally say this partnership has taken off. I am leading from the GYA, and obviously we have a team from the ISC. And what gives me hope in that is that we know as the GYA, we are termed as emerging and middle career scientists, and we are working with what we consider the ISC to be the powerhouse of science. But what gives us that hope is that we are looking at where people are not able to take up spaces in rooms of science. We are also looking beyond that. But the hope and the reality is that if we can come together and as a collective and collaborate, interdisciplinary, multidisciplinary, transdisciplinary, it gives us the sense of solidarity that we may not have the same issues, but we can place ourselves in those situations of people experiencing barriers in terms of visa restrictions and how we can work as a collective. Thank you.
Thanks. Brings us to Marcelo.
Well, good morning. I would like also to thank for the invitation. In fact, turning back to the World Cup, I was born in Argentina and I lived in Brazil, so I have two shots. So, but using this analogy, I would say that it's absolutely fundamental to invest in talents. When you see the World Cup, you see the France team, the Netherlands team, the German team. Most of them have the base of players from Africa, or coming from Africa, of course, from this terrible colonization that we had in the world. But they already realized that without having a real global enterprise, we cannot develop. This is for Europe especially, and from the global north, I think this is a lesson to be learned, to invest in talent in the global south. Otherwise, we will not have talent enough to keep doing what Robert just said. So I think that talking on a good example, I am now as an executive director of the World Academy of Science that was started 40 years ago by a Nobel Prize awardee, Abdus Salam, who believed that investing in this talent was absolutely fundamental. To invest in excellence in science in the global south was the future. And he was right. He was absolutely right. And he was from Pakistan. And without knowing how to speak Italian, he convinced the Italian government to invest on an organization to work for the global south. This is why we are in Trieste, Italy, because we receive a core funding from the Italian government, and he managed to put that in the Italian law. This is why we are a little bit protected, because it's in the law. So there are countries in Africa that all the PhDs were formed because of a fellowship from TWAS. Otherwise, they would have no chance. So I think this is a mission that we all have to think about together, not only with the capacity building, with the infrastructure, but also now, more than ever, all these organizations that we represent here, we should work more on communication. Without good communication, we will have a lot of problems. So this is, I think, something that will unite all these organizations working on science to really speak to the society the importance of science for the future. So this is a priority, in my opinion. Thank you very much.
Thank you.
Yeah, thank you very much, Michael, and thanks for all of you for the invitation of being here. So I'm here on behalf of IAP, which is the Inter-Academy Partnership. It represents 150 plus science medical academies, also a bit more social sciences and humanities these days around the world. And being part of an organization like this, but also being at a meeting like this where we convene with scientists from around the world is very inspiring to me. And the fact that, as you said, we should act more as a unified community, try to coordinate all the activities that happen within the different networks, whether it's around the globe or in Europe at Alea, is extremely important at the moment. The one inspirational example I want to mention, though, right now is more personal. And that's because I am in the field scientifically of building synthetic cells, which you were referring to as the muddy middle. We can now learn about life and learn how to construct it. And I'm not a young scientist, but I work with a lot of young scientists. But from that role, I'm also part of the bioethics committee of UNESCO. And being in that committee for now almost 2 years has been extremely inspirational to me, because you see really the global south very well represented. It's a committee from around the world, with the perspectives from around the world, with the perspectives from local knowledge, with a deep conviction that science should be there for the good of all, for the whole planet, for human rights. It's very strong on social sciences and humanities. So being in a committee like this, seeing the passion to really act together, how to think about using AI and how to develop it in a responsible way, I think is extremely inspiring, and we should really keep doing that as international organizations.
Thanks. Here.
Well, perhaps I'm most inspired by the past. Marcelo, you already mentioned the visionary leadership of Abdul Salam. For me, for instance, a good example is the International Geophysical Year. It was in 1957. And in fact, it was organized by the ICSU, the predecessor of ISC, in the height of the Cold War. So 67 countries participated for a full year. It was the time where they could finally study the Earth as a whole system. To everybody's surprise, the Soviets were first with Sputnik, and then American satellites came. Wonderful discovery, the mid-Atlantic ridges, the Van Allen belts. It led to the most successful diplomatic initiative almost in world history, which is the Antarctic Treaty, which safeguarded the Antarctic as a space for science, not for military development. So actually, honestly, I think most of us know the subject of our own field. So I can tell you the history of physics. I didn't know so much the history of international collaboration because we are growing up in these silos. And there's so many examples. And I think we should be honest and say, well, wow, you know, these were breathtaking, ambitious initiatives in really, really difficult times. And I think the answer that we should be able to give if people say, well, in 2026, where there were obvious, you know, again, big challenges, what was the equivalent you did? And that means that history put the bar quite high. And I think we should be inspired by that.
Thank you, Robert. These are very nice examples in this first round. So this gives us a bit of the opportunity to shift gears. Our topic is very broad here. It's about the public good that we are trying to all protect. So science as a public good, of course, is very important. I think, Robert, you outlined many of the issues in your 6 points earlier as well. But at the same time, there is also competitiveness. There is also nationalization. You have one country pitched against another. And it's also about being the first mover of taking the advantage, winning the race to space, you know, after the Sputnik shock, for example. And the question is, how can we maintain it a public global good? What can we do about these other interests that are competing against them? What can we do as scientists in this area? I know it's too big a question, but that's what the GYA is here for. Maybe we start with you, Robert, and then we can mix it up a little bit.
Give people time to think.
Exactly.
Well, again, I said, you know, we should not be naive. There are huge economic advantages, and we have a lot of talk about autonomy in many ways. Countries want to be autonomous, you know, regions want to be autonomous, etc. And I think it's perhaps, you know, too easy to think that just we aren't able to unify plugs and sockets, you know, to have a. But I think we need a more careful understanding. What are the areas where we are competing and what are the areas we are collaborating? And I think in many areas, there are huge parts that actually it makes sense to interchange information without, you know, making your country or your industry at risk. And here we need the scientists. So I feel governments often, they act with a big, very blunt instruments because they lack the in-depth knowledge where the areas where collaboration makes sense. So it can be in the self-interest of a nation to collaborate. And now, just one anecdote. I was talking to somebody who said, you know, we think of science and knowledge as this leaky bucket. So, you know, it's kind of streaming away. But it's also important, how fast do you fill the bucket? How are you able to attract talent? And I think we need more advocacy on the behalf of the scientific community to look at the positive sides, because the negative sides are so much in the interest of people right now.
Great, thank you. And I see Marilyn already wants to add something as well.
Yeah, maybe to continue to this topic, a little bit of experience from being an academy president, and I completely agree. So as a scientist, on topics like this, you need to spend a lot of time at this fractal interface to understand what is at stake, what is the way of thinking from, for example, the government. And we had this discussion in government scientist role a few years ago, specifically about, for example, in the Netherlands, how much do you want to protect your knowledge? How much do you still want to collaborate? And what is the way to protect your knowledge? And pushing back and emphasizing how important international collaboration always has been, and especially for a small country will be in the future, is extremely important. And not just by saying, no, you shouldn't do this very strict law, but have a discussion, have a dialogue, try to understand what is at stake. And then my experience is, if scientists do that, also young scientists, extremely important that young scientists are involved in this discussion, in this dialogue, then you create understanding from both sides, and you get much more subtle measures The law that we were talking about a few years ago actually was just thrown away 2 weeks ago, and we will get a new one that is much more subtle than the original one. So it's very important to be persistent, not go once, twice, to keep involved in this dialogue as an active scientist, as a young scientist, because you are the ones who know in depth what your field is about. So to make it possible to, to strive for much more subtle measures than are otherwise will be the case.
Thank you. And maybe, Kerstin, you want to add to that as well?
Yes, I actually wanted to add something about what you said about the humanities, that they were sidelined. Now, I'm a historian, so this is very dear to my heart, but next to some self-advocacy for my discipline, I actually also think that as a scientific community, we should always emphasize that we are at the service of politics, but we're not entirely instrumental. But at the same time, we should also push back against the perception that there are scientific disciplines that you can use more readily for political purposes, and then you have these others, like the small, as we call them, the small disciplines or the minor disciplines that are sort of given a bit of a niche existence and are a protected minority. I would rather say that the humanity, so protecting the humanities, for instance, is also important from epistemological point of view. Meaning, if you have scientists collaborating, interdisciplinarily collaborating, then you gain insights through the humanities, for instance, for the sciences, that you wouldn't otherwise, and actually vice versa. I've collaborated with psychologists on a project on successful aging. And of course, people age through time, meaning there's a historical context in which they age. And I think we both learned, both disciplines learned much about it. And I think this way of considering how different disciplines actually contribute to insights and epistemologies has much to do with protecting integrity of research. The integrity is not just adhering to scientific standards, but also considering which discipline helps you to understand current issues. So I would say protecting diversity is not just because diversity is good per se, but because it actually produces better insights.
Great, thank you, Kerstin. And I think Abdul Sattar wants to add something.
Yeah, thank you so much. I just wanted to mention something, since I came from Iraq, like a past conflict area, and especially I'm from Mosul, and you know what was happening in Mosul in 2015 after the ISIS one. I'm talking, of course, they destroyed everything, and I see the reality of the education at that time for rebuild the society again. And we moved to, for example, to Erbil in that time. We established the university. So I think we needed really to protect our international collaborations and to make the balance between our academic, here in Germany or different places, and also with our government. You know, the government always have how to say, security concerns and the big question mark, for example, what we are doing right now. Can you explain more about this academic? What exactly you wanted to, impact in our society? And for example, one example at that time, we are really fighting just to make sure the children, the refugee camp return back to the school. It was very big challenges for us as a young scientist at that time. And with the AGI, I was really feeling is more easily also, to present some international collaborations. And at that time also we creating the mobile library, and we started really to deliver different curriculum to different also society. And dealing also with the minorities, especially in the university, and dealing with the students is not easy at all for also, young scientists. So my belief here, science is move forward when the knowledge is shared. Thank you.
Thank you for sharing, Abdul Sattar. And that brings us to Natisha.
Yeah, thank you so much. I think the panel has so far said some of the things I'd want to do. So I want to push us into another shift as we talk about nationalization of science. And I think we've heavily focused on capacity building, but we should now be shifting into what we call capacity sharing. And I think that is so important as we tackle global North, global South collaborations, is that if we want to make this positive step, or to create this positive step, we need to start thinking beyond capacity building and asking ourselves, what can we from the global south share with the global north? Because as Marcello has correctly said, there's so much of things that are untapped, especially considering science in this global south. And if we continue to have these conversations 5 years from now, we'll be sitting and saying the same thing. And we have not tapped into those possibilities and explored them further. So I think it's a direct shift of wanting to change from capacity building to capacity sharing. Thank you.
Thank you, Natisha. And that's a great transition to Marcelo, who's also was in the Global South in the
Yeah, I would like to add,
Brazil.
I don't know, a personal perspective, and nobody mentioned it yet. If this conference was organized last week, we couldn't be here because there is no air conditioning. It was 40 degrees, and the global change it's now concrete for most of the people. I arrived on Sunday to Germany. I had to take a train in Hamburg station to go to Berlin, and it was like the hell. So it was 40 degrees, and then under the roof it was about 60, and there were thousands of people, and the trains were not working, and it was a mess. And then I arrived to a hotel, no air conditioning, and it was impossible to sleep. And in this situation, from my elite position, I was in a hotel, in a very nice hotel, without air conditioning, and I said, what is happening for the people that have to live this every single day? Every single day, and we don't pay attention to that. I hope that at least this situation will wake up societies that have to deal now with a situation which is quite normal in the Global South. And I think that we should use, as organizations, this moment to use a good communication and really reach the people and say, the only way to solve this problem is through science. We have no other exit. So we should try to be more efficient in this communication, in this dialogue with society, in order to really, really tackle complex and difficult problems. It's easy. We know that it's not easy. But we have to at least have a clear understanding from the politicians, from the society, that without science, we have no future.
Thank you, Marcelo. And that brings us to Kirsten.
Yes, I just wanted to respond to the two of you because I absolutely love the term capacity sharing and also what you just described about personally experiencing what this means. Because I had the feeling that, especially post-COVID, there was this idea that everything can happen digitally, but science is still personal encounter. And I think this is actually where institutions can come into play and provide the space for precisely what you're saying, personal experience, personal encounter, where this happens on a level that is not just abstract, that is not just communication, but actually communication in person. So thank you.
Thank you so much. Maybe going back to this initial question, I think there are two areas which are instructive. It was already mentioned that like Antarctica, for example, is protected and so used to be space. You can't have a moon colony despite advertisements telling you that you can buy some patch of land. It's not true. You can do it, but it's not yours. Yeah. So that's sort of what we agreed on a long time ago. But now there is a renewed race to space, 20, 30,000 satellites in the next 10 years. And this is also projecting power. Warfare has changed if you look at the Ukraine, for example. And we see this in many other areas as well, especially for AI. I mean, due to the current situation, the most powerful AI models are based in the US, and they're being turned on and off depending on, let's say, political considerations. And maybe this is a question for this panel as well. How do we act in this situation? I mean, there is no solution, obviously, but who is the right actor to either push back or to put limits? Is it the government? Is it the GYA? Is it the Junge Akademie? But how do we deal with a situation where everything is changing? Like open sea passages, this was already settled 100 years ago and is a renewed thing if you look at the Strait of Hormuz, for example. I'm not sure who sees themselves Yeah, sure, Marcelo. This,
Well, this is, I think that Robert already mentioned that in his talk, but I think this is the power of the multilateral system that was built after the World War. And it's, of course, we have now a challenge to keep it working. We know that the organizations became rather big, rather complex, rather bureaucratic, but they are fundamental for the future of this kind of governance of very complex areas, like mentioned before, of the global health, of the Arctic, Antarctic. We have the space, we have the oceans, we have many, many discussions that can only happen with diplomacy, science-informed diplomacy, and a lot of patience and understanding. But again, I'm sorry that I'm repeating this, but the role that we have in this area is, of course, keeping working. It's very complicated because we have to keep a balance between working in our own fields, in our areas, and the advancing science, but at the same time, we have to be advocates for science. We have to speak out and loud for science, for autonomy, for the university's autonomy, for the academic freedom. Otherwise, we will not keep doing what is necessary. So we have to build a kind of different scientists that we were used to be just in the lab or just in the group. We have to participate in the public debate in order to make science visible and really clearly important for the future. And of course, gain trust again on the multilateral system, which is fundamental for that.
Thank you, Marcelo. And that brings us to Marilyn and Robert afterwards. Okay. Sure.
Yeah, maybe I can add a little bit. So I completely agree. And it's also what you said earlier, as a community, keep pushing for scientific values. So it's the independence, the academic freedom, the openness of data, the sharing. Maybe we have to rethink the whole IP system, although apparently that goes a bit far. But we had these discussions also in the bioethics committee. How do you prevent that a lot of research which is happening in the private sector right now and not in the public sector, which may not be open, may dominate the applications in the future, and it will not be to the benefit of all. So how do we early on think about the governance and keeping it open and keeping it spread around the world and not in the hands of a few? And I think with a lot of this technology, that's a real challenge we have. So as scientists, continue to give the examples of how multilateral cooperation and openness can have a broader benefit. We have to keep producing examples like we have seen in the past, and push back on anything that is trying to prevent this.
Yeah, thank you. Very important point.
Yeah, so it's a good question. And actually, many of the topics you mentioned, there are already structures there in the intergovernmental structures. So in fact, there's an IEC affiliate beta COSPAR, which deals with radio frequencies, etc. So the idea that everybody's shooting satellites, tens of thousands, I think, even there's 1 million, Elon Musk applied to send in 1 million satellites. And they're big issues, by the way, because you get incredible traffic jams. They create, avalanches, etc. So this is something that, again, is something that needs to be discussed. There are weak, but there are intergovernmental organizations. The thing is, they have to be fed by science. So I think, what you need is the scientific community informing those bodies. And as we all know, as working scientists, really, the details matter. So, it's not about grand statements, it's about what are you doing your research. So here you need very detailed advice. Oceans is another good topic. There are treaties, Of course, some countries are not part of those treaties and they start deep sea mining. But just one example, last year was the International UN Oceans big conference. In fact, through the IEC, but through the scientific community, we engage many of the small Pacific island states, which some of them have only 10,000 people as inhabitants. So it's very difficult to be a serious scientifically informed partner. But we created this kind of networks of scientists in the Pacific, brought them to these meetings, particularly, again, the young scientists, also people from other stakeholders to bring their perspective. So what we can do, I think, is, inform those diplomatic circles, bring actually people to the tables, have them speak. It's very powerful. Actually, coming to your points, it's very powerful for people to speak on first experience and share those thoughts and inform the diplomats that have to do the work. But there is a whole infrastructure that we can interact with.
Yeah, that's great. Thank you, Robert. And it brings us to Kerstin. Oh, Natisha, sorry.
Yeah, thank you so much. So I think from what the colleagues have just said, it touches on equitable collaboration. And it speaks to the fact that who sets the agenda, who gives the funding, who brings the partnerships, who has the loudest voice for that project or whatever collaboration is going to take place. And I think that's important, especially at the grassroots level, where we've seen this happen in the global south, agendas being set in the global north and having to be a collective follower rather than an agenda setter. And so I think that whole positioning needs to be changed. And as Robert had correctly said in his keynote address, is about working as that collective from the very beginning. We all know this, is that policymakers are always time-sensitive people. And here we are as scientists wanting to do research over 3 and 5 and 8-year periods. And so it speaks to the fact is when we're setting those research collaborative agendas, that we should be speaking in the same voice at the same table. And we should be speaking about milestones and goal setting that speaks to both the policy and the science interface. Thank you.
Thank you, Natisha and Kerstin.
I actually want to address something also from your opening remarks about how this interface could actually look like. Alea has just published a statement on Science Knows No Borders. It's open for comments. And so one response by somebody was actually, aren't there many statements about that already? And I said, yes, there are. But then again, this is an ongoing process and it needs and what we have is not just there. There's not just one statement said, but what we have needs to be continuously re-won. And I think it's first, it's important to not let go, to always continue. Not just because everything needs to be updated, but also it allows us continuously to integrate the voices that you mentioned. So some voices we're missing now, okay, we integrate them in the future. And sometimes I think that at this interface, we're not doing what we do as scientists, namely continuously updating, continuously keeping on track, continuously working on it. We're saying, here's a statement, and now there's a tick. This topic is done. And I think understanding this really as an ongoing process that starts, so as we say in German, after the game is before the game.
If I can just say one word, my experience in science, you always ask what's new, you feel very a lot of pressure to come with something new. In politics, you have to repeat again, again, and again, and again. And I think that's a bit with these kind of statements. Yes,
in politics and lecturing. So great. I think we touched greatly upon this area of segmentation of research and what we can do about it. Maybe another aspect, a third area, would be the changing geography of research as well. Like, where are the power centers? How do we interact with each other? And Abdul Sattar, he comes from a lower income region, and there is also a perspective here on how to meaningfully interact with the global research community. So maybe you want to have the word.
Okay, thank you so much. So, like, excellent research is no longer limited to the few countries, it's my opinion. And nowadays, exactly, we can see, the real collaborations. For example, with the AGYA, we have equal voices from the Arab and German, members. And honestly, we're sharing the responsibility and the leadership. So in this case, build the trust between the members is very important. And of course, you will see yourself, you are almost equal with anybody, any differences between okay, even talking about the Arab world, from Qatar to Mauritania is totally different, income and different levels and different infrastructures. Because of that, we consider all the points, especially when also we accept new members. Last week, I have been with the committee, we consider all these challenges. We appreciating women, for example, from Mauritania, we know she's traveling far away from her hometown to be in the hotel just to have the internet. You can imagine the challenges here. And of course, we are so happy, and end of the way, we are in the same platform and we are doing amazing job. also to like helping our society. And we're so proud also to see our outcomes is implemented here in Germany. So this, like, as I mentioned, like equal voices is make me like more motivated to contribute more and more in this collaboration, in this committee.
Thank you very much. And Marcelo, please.
Yeah, I would like to share with you some recent data on this. The data is in fact from 2024, but it's still valid, and of course even more. Nowadays, 60% of the papers published in the world have an author from low and middle income countries, 40% from high income countries. And this figure was 13% 30 years ago. So it's the geography of science is really changing. And if you take, of course, if you consider there's a big player here, which is China. If we take out China of the equation and consider the 27 biggest producers of science in the low and middle income country, and you compare with 27 Europe plus UK countries, the production of these 28 countries is bigger than the Europe and UK. So even taking out China from the equation. So this clearly shows that the geography of the center of gravity of science is changing towards the global south. And this is, again, something that it should be realized by the global north, that it's a forward-looking strategic change to collaborate with the global south in order to, to keep the future of science, to keep the stream of talents to develop the challenges and to tackle the challenges that we have for the future. So this is something that we don't pay attention too much on that, but I think that we should.
Okay, great. Thank you, Marcelo. I think so the changing geography in having the global south as a talent pipeline is one aspect of it, which creates some kind of imbalance. How can we create a more equitable research agenda where everybody can contribute more equally? I think this will be one of the big questions that is also a big topic for us in the Global Young Academy as well. And maybe I thought, Natisha, perhaps you have some input here as well.
Yes. So we know as the geopolitical tensions continue, funding has become really constrained. And that's not just in the global south, but also in the global north. And I think if we want to move towards equitable research and equitable collaboration, then I think we need to be looking at who are our funders and do they know the context? Because often enough, we find in the global south that a grant that would have taken us approximately 5 pages to write becomes 10 pages of context. And in my case, coming from South Africa, I'm having to always explain the African context that a funder may not necessarily know. And so I think, there needs to be these shifts, and these conversations needs to happen very early on. So there needs to be a whole lot of stakeholders and role players speaking at the very beginning. Of course, your funder is important because that's the person with the money, but should they hold that right to how the research should be done? What about flexibility? If we're saying we're doing equitable research, it needs to be flexible. It needs to be according to the needs of the communities that are burdened by something, rather than what the agenda has been set by a funder. Thanks.
And Robert.
Yeah, this is actually an area where the IEC is very, very active. Wrote this kind of very good report about flipping the science model. I think what we see is that, as I said, what we really need is to see the science in action. It has to deliver results. And I think, this is also upon us, right? Because we make the promises, but do we also show the results? And that means that you have to work transdisciplinary with many more stakeholders. In fact, in those areas where it matters most, because you want to have the impact. And so we really need different funding models. And I think there are lots of opportunities here because it's since you work, across borders, it's not just about, just supporting research. It's actually addressing issues, whether it's agriculture, whether it's health, whether it's climate, etc. So we somehow have to rearrange. That's kind of a big task, kind of the funding streams. And you see some of the philanthropies are a little bit more in tune with this. They also think a little bit more broadly. National governments increasingly think nationally. I mean, one thing I really, really worry about that we have seen just in a few past years, tremendous cuts, and not only in the US, but also many European countries in foreign aid, etc., because it's the kind of least politically attractive area. And in fact, if foreign aid stops, I think that actually was usually an important element of supporting that kind of research. We have seen tremendous holes in public health, surveillance, etc. So, we have to make the case this is not only about research, it's really about many other funding streams.
Thank you. Very important contribution.
Just a word. There is also the other component, just to mention about, there are what we say in physics, the boundary conditions. So last month, we organized a workshop, of course, with the Global South, which is our mission. And out of the 10 invited speakers, 4 were forbidden to come because of the visa issue. So this is also impacting somehow the global world of science.
I think this is a very important point, barriers which are imposed. How can you access? Not every passport gives you equal access, unfortunately. Yeah. Marilyn, please.
Yeah, maybe just to continue on that, because I really think it is a big question mark, a big challenge, the whole funding scheme, and it's happening also in European countries. You said there was a more emphasis on economy related research. So the funding is directing a lot everywhere what we focus on, and this prevents, I think, this capacity sharing, this setting an agenda from the local needs wherever it is around the world, and the challenges we have on a global scale. So maybe it's also something for you to really think about, be really creative. What could be really alternative, maybe idealistic for the moment, ways of going about funding science? Is it philanthropists? There are some really, I start even meeting them in my field, very rich people who want to contribute somehow, but what is their agenda? Is that the right way to go? With the global initiatives diminishing, like you were saying, it's really a tough spot that we are in. So what could be really creative alternative ways of doing this? And are there maybe ways to set the agenda in a sharing way that do not need a lot of money right away, but that can set examples? So I think it's extremely important to think about this.
Thank you, Marilyn. And thanks to Kirsten.
Just very, very quickly, because we had 2 years or so ago a meeting with several young national academies in Berlin, where we were actually talking precisely about how the young academies can function as a hub or a facilitator of precisely that. And we came up with something that we called peer boosting, because we thought that very often it's not just the missing knowledge of maybe funders, but also sometimes systems or standards are really unintelligible if you look at them from the outside. And to increase the legibility, or to help like other postgrads, for instance, where the young academies are very active, help other postgrads with reading the system, reading the requirements, which can actually also already be a barrier.
Yeah, and maybe this gives us opportunity to also see if somebody in the audience wants to contribute from their own experience here as well. Since so many questions were asked into the audience, it's their time to shine now. So Martin.
So something I'm wondering about, if we look at global research networks, or networks that brand themselves as global. Very few of them are really global. They evolve around the same set of countries. And it's not a matter of global north versus global south, because there are significant differences across the global north, and there are even larger differences across the global south. So how can we do better? And specifically, what could I do tomorrow to make things better?
Okay, great. Does anybody have an answer here. Then maybe let's collect more questions. Yeah, exactly.
Thank you so much. My name is Emilia Stoimenova-Duha, member of the Global Young Academy. I always remember the picture that Robert showed us. So we have the clouds and we have the black hole. And I think I love your discussion here. We are speaking about collaboration for science as a global public good, but this is somewhere in the clouds. This is the illusion. On the other side, we have the European Commission funding Choose Europe. Also, the director of the World Academy of Sciences mentioned why European teams are winning, because we have African players. So what do we want to do now in Europe? We want to collect the best talent, not only from Africa, but also from other parts of the world. So we have science on one side, speaking about collaboration, about global public good. And on the other side, we have politicians who think about their own benefits and economic good. So what can we do about that? Maybe not to live in illusion, not to be in the black hole, but somewhere in between.
Thank you.
Yeah. Any more questions?
I think there was one more in the back. Yeah. Thank you.
Thank you. This is Yolanda Lopez from Mexico, an indigenous scholar. The whole session was about the importance of science, but perhaps there is an issue that we forgot to hear, that there are some knowledge systems that are here and were here before the mainstream science. And my question is, for example, you also mentioned about the diplomatic approaches to the Arctic, and all those processes were started by indigenous people. So how do you see indigenous knowledge or local knowledge or citizen science as part of this tool for understanding and managing global challenges worldwide?
Okay, great. So maybe one more, yeah? Mm-hmm.
Thank you. I'm Mohammed Hosseini from Northwestern University in Chicago, and a member of Global Young Academy. Robert, I really appreciated your point about weaponization of science. I think some of the people here might know, but just as a reminder, the place where I am based in the United States, the Department of Defense is the largest contributor to science. Their budget for funding scientific projects is probably 4 times the NIH. And I think in the last few years, you're seeing a sort of similar trend here in Europe, where there's a lot of money being pumped into military, like in the Netherlands, for example. I've heard that the number of people who are part of the army is going to increase to 200,000 from now around 35, 40,000. And I can imagine that many of them would become scientists or people who are some way or another involved in science. What do you think institutions like the International Science Council can do to prevent science becoming weaponized and science becoming militarized?
Great, these are some deep questions. You have 30 seconds. Maybe that concludes this session. Maybe we can, if you have answers, chime in.
I won't answer all the questions because it's really like to hear the viewers of the panel. I mean, perhaps raise the question about the interface between science and politics, right? Because she said, you know, it's easy to. I like to say that politicians are typically paranoid, and scientists are being naive. That's the caricature. But I like to say, well, politicians are particularly paranoid about scientists being naive, right? So. And I think, you know, one thing that we need to do is understand more the both systems, because, you know, certainly in democracies there is an important point. You can have your various points of view, but, you know, you might be in front of parliament, and, you know, people might vote and might have certain opinion. You have to deal with that. But I think it's really important that those in political and in policy situations are well informed. And I think this is one way I think we can concretely do. So I think there are many initiatives in many countries where scientists, or particularly young scientists, they interact with political parties, they do things in parliaments, they inform policymakers, they go to civil servants, or often forget that. You know, the real decisions are made often by people not at the very top of ministries, but they need, so just get close to that border. inform them, build friendships, inform them. I think that's an incredible, powerful way to indeed be at that kind of middle ground where you somehow, you're not yet quite in the black hole, but you're close to the horizon. If you're a physicist, you understand what I mean. You're not being sucked in, but but there are lots of, you're being stretched out, etc. It's very uncomfortable. But so I think that's something, that area we need to be. And then I want to say something about indigenous knowledge, because I think that's an incredible, powerful point. And I briefly mentioned, transdisciplinary, but there are indigenous traditional sources of knowledge that are absolutely crucial. And often people say, well, what do you mean by transdisciplinary, etc.? I say, well, if you go to the physician, you will say, well, I feel this and this and that, and you're participating in that knowledge conversation. And you would love your physician to listen to you and what you feel. And so I think this is in a much larger scale. What do countries feel? What do people feel? What does the planet feel? I've seen many examples, for instance, coming back to the case of the Pacific Island states. There is such incredible knowledge from people living in those countries. And actually, in some sense, their frame of thinking of what's happening to their world that's literally disappearing is so incredibly powerful. And I often feel we lack even the language to frame it in science. And we need those other frames or something which are much more intimately connected to the topics that we care about. And they have to find a role. But again, we should be expanding. So I think we should welcome those. It's not about science on the one hand and other sources of knowledge. Just include them, make them part of our community.
Thank you. Very powerful. Okay, Marcelo then, and then Kirsten, and then
I would like to try to reply to this important question about this perspective on these collaborations that usually had, a clear way, not bi-directional, but unidirectional way, and trying to get the best from the talents that we have in the Global South, for example. We are living in a world which is really changing day after day. In some countries, it was even forbidden to lie, for a politician to lie. Now it's perfectly fine. If a politician lies, they stay there and say, okay, I lied, so no problem. So the world is changing very much. So we have in science as well, maybe coming back again for what Robert said, is we have to find a way to do something really, really complicated, which is a social contract on science and how science should work and what is expected or not. Just to mention the example that was given. So it's important for any collaboration with the Global South that there should be a component of avoiding the brain drain. Otherwise, we are not doing a good thing. We are just perpetuating the colonialism way of that the global north had always lived with this kind of colonization mindset. So we have to insert that also with the traditional knowledge, with the local communities, the local knowledge and so on, and to keep and work on the development on the local infrastructure, local talent, and so on. So this is extremely difficult to make, but at least we have to think about it and to start developing that. Without doing anything, we will certainly not advance.
Thank you, Marcella. And Kirsten.
I would actually like to second that and would like to offer sort of aggregate answer to some of the questions, because from my experience, both in the German National Young Academy and with Alea on the European level, and maybe you can say something about that as an active or formerly active politician, my experience was that collaboration and communication works best if you're very concrete and precise about the topics you're talking about and actually define what you mean by what you say. And this brings me a bit to the question of, for instance, indigenous knowledge and also different systems of knowing, that you don't just assume a normative definition of, for instance, knowledge, of, for instance, public good, but the question, what is actually meant by this? Because then you can actually involve different stakeholders. This also means that from time to time you have to acknowledge that there are certain values or maybe definitions or ideas that are actually in conflict with each other. And this needs to be addressed as well. A very specific example about bringing scientists together. We wanted to do a meeting within the Young Academy, and then was the question, who is actually traveling to where? And then some said they have decided to not fly again. But then scientists from the global south actually say, why are we supposed to fly all the time? Simply because then you can say, I'm not flying anymore. And so how do you actually square these different things? And I found that, so first, it works well if you're very concrete. And second, we were talking about division of labor. Not every institution, not every group needs to tackle everything, but you can actually part the work, and then can exclude some elements that you're not talking on, which another institution that may be actually more competent can then take that on. And I think this sort of working together, not by everybody doing everything, but skillfully dividing the work, plus questioning what we actually mean by the terms and the concepts we're using. Not saying we should need to deconstruct everything. At some point, you have to have a settled definition, I understand. But nevertheless, I think a sort of self-reflective approach to the concepts we are using in what we are actually trying to achieve would be also helpful.
Thank you, Kirsten. That brings us to Marilyn.
Yes, I'm not going to give direct answers to the very important topics that were raised, because I'm also wondering, and it's a real challenge. But with the things that we're now discussing, I think we are touching a little bit on one of the topics we didn't discuss so much, but a little bit, is our scientific system and how we've organized it from within, and that it really needs a change. And that includes what, the definitions, what kind of knowledge, what is the local perspective, who sets the agenda, who is funding it, and how do we treat people's careers. And we are still not a little bit stuck in many places in this way. We've been doing science for decades. The publishing habits, the fact that everything needs to be in English. Well, how do you get promoted around the world? How do you get the opportunity to move back to your country where you were born, where you would like to build a career? So all these things, and again, it's on your shoulders. But all of the scientific community, especially the older scientists, should really help here to rethink this, because otherwise all the challenges that you mentioned will be even harder to achieve.
Thank you. So the conversation never ends, obviously. So the GYA is bringing people together. I saw a raised hand. Okay, sure. We're here to discuss.
Yeah. I'm sorry, I was gonna raise my hand, but I'm very happy we're having this conversation. My name is Professor Choma Dezinyige. I'm a professor of criminology from the University of Port Harcourt, Nigeria. And I just want to give practical examples of what's going on, so that when we want to, because we do have challenges, when we want to find solutions, at least we should know what exactly are the problems. Now, for example, the issue of bringing best minds from the global south to the global north, it's good, right? But what's the implication for the countries where they have left? There's now human resources have left those countries. And so there's a lacuna in those countries. Those countries now remain still underdeveloped. Now, there are some funding situations whereby you are brought to the global north, trained for a couple of years, and you are asked to go back to your country of origin after the 3, 4, 5-year training. But these are, for example, I'm not a lab scientist or these things, but I have colleagues who have expressed frustrations that you come to the global north, you have access to equipment, and you're taught different ways of doing things. And after then, you are not sent back to your country. Such equipments are not in your countries, such facilities are not in your country. Your knowledge kind of is stuck in one time a stage or something like that. So you can see the challenge here. And I'm somebody who is always, I like finding solutions to problems. I want to, because I currently head a center in Nigeria. I've had that privilege. I'm the director for the Center for Peace and Security Studies at University of Port Harcourt. And we have a PGD program, master's, PhD, and yeah. And one way we are able to give our students, teach is in a hybrid mode. So students, and I have students from different parts of Africa that you come in for classes online, but that's internet. And what kind of internet am I using? Starlink. I don't know if any of you know, but I don't know how it is here, but it's very expensive to install it, and then you pay monthly subscription. Now, when I'm getting funding, when we apply for funding, if I'm collaborating with an institution in the global north, they always put restrictions on what I can fund, what can be bought, and what cannot be bought. If you want me to be able to continue in this collaboration where I'm coming back from, then I should be able to have the facilities. We can't continue to keep putting restrictions. And I know many of you have mentioned these challenges, but we need to be specific. We need to be intentional if really we want to bring about positive change.
Thank you.
The world is global. What affects one part of the world affects the other part of the world.
Yeah.
So we must work hand in hand. Thank you.
Thank you. Thank you so much for sharing this. And I think that's in good tradition of the Global Young Academy as well. The conversation doesn't end here. It's just the beginning. These questions that we have here, we are putting them into our working groups, these inputs that we have here. So there's plenty of time afterwards with the coffee break and the subsequent discussions to take the raw energy of the people here, their backgrounds, their disciplines, their different concerns as well. And that's what makes it so great. And that's what is one of the core strengths of the GYA. So let's thank everyone in the panel here for this great discussion. And I'm looking forward to the rest of this event.
Thank you very much. It's been a great start. And we have a small present for our speakers, our panelists. It's a 3D model of something very typical of Bremen. There is the Bremen musician with GYA 26 and Conservatory University. That comes from our Makers Lab in the university. So, please. Let's take a picture with the panelists. Picture time.
Yeah, let's take Oh yeah, with the musicians. There's a story here, we'll share it later. Three, two, one. One more time. 3, 2, 1.
Now we are having a coffee break. Please come back to the room by 11 for the second panel. And at the back, you can wrap. At the back of the room, it's possible to wrap the gift. Please have a seat.
Excellent. I like it. That's very, very good. Thank you. Thank you. Thank you. It's so exciting to be here and see you so excited chatting. That is the best, you know. I'm sorry that I interrupted, but we have a really good conversation coming up. So thank you for being here again. Now I'm down. Okay, Francesco is going to replace me right now.
So we are ready to start the panel one, because before it was a kind of an introductory panel. And the panel one is focused on AI governance for a shared future, science, policy, and global equity. So it's my pleasure to introduce our moderator that is already on stage. It's Lutz Milibet Kumba Garcia, founder of Sea Policy Global, and is one of our GYA members. We're very honored to have you on stage and moderating. Thank you.
Hi, everyone. Good morning, buenos días en español. Welcome to panel one, AI governance for a shared future, science, policy, and global equity, which is actually a theme very close to my heart, and I tell you why in 1 second. I'm an immunologist, I'm a policy advisor, and I'm a science communicator, and I work at that intersection of science, policy, and society. My career has spanned government, international development, science diplomacy, including roles at the U.S. Department of State and at the U.S. Agency for International Development, or USAID. More recently, I started my own consulting, Sci Policy Global Strategies, and my work has expanded to a lot of areas that I never imagined. One of them being emerging technology governance, including AI-enabled biological risk, AI applications in health and wellness, and the policy and regulatory questions these technologies raise. Never in a million years, and as an immunologist, I thought about that. So this experience that I have had through my business have reinforced me the importance of ensuring that AI governance is evidence-informed, is globally inclusive, and responsive to societal needs. It is a pleasure and a privilege to moderate this conversation today with the esteemed panelists that we have here. AI is often described as a technological revolution, but AI is much more than a technology. It is increasingly shaping how knowledge is generated, how decisions are made, how resources are allocated, and ultimately who benefits from that innovation. In that sense, AI is not only transforming technology, it is reshaping power. This creates enormous opportunities. AI has the potential to accelerate scientific discovery, improve health systems, which is close to my heart, support climate adaptation, expand educational access, and help address some of the world's most pressing challenges. Yet, these opportunities are accompanied by equally important questions, which are: who developed these systems, who governs them, whose values are embedded in these systems, and who gets left behind or who benefits from it. Today, discussions about AI governance are taking place around the world, not only here. Governments, international organizations, academic institutions, and industry leaders are developing new frameworks, regulations, and ethical guidelines to guide the responsible development and use of AI. These efforts represent important progress, but they also reveal significant challenges, and that's why we're here and we're having this discussion. One challenge as a Latina, as a minority, is representation, not only in AI, but also in other areas. Much of the global conversation continues to be driven by a relatively small number of countries, institutions, and companies. Another challenge is implementation. It is one thing to develop principles and frameworks, yet it is another to translate them into practice across different political, economical, and cultural contexts. And perhaps, most importantly, we must ask whether AI governance will help reduce inequalities or whether it risks reinforcing existing gaps between regions, sectors, and communities. And this is very important for you, young scientists. Early career researchers are not simply future stakeholders in AI governance. They are current stakeholders right now. You are developing new technologies, generating evidence, advising policymakers, and helping shape public understanding of these emerging technologies. Your voices should be part of these important conversations from the beginning, from today. Today's panel brings together three outstanding leaders that I admire a lot, whose experiences span ethics, public policy, technology governance, digital transformation, and responsible AI implementation. Together, they offer complementary perspectives from international organizations, government, academia, and industry. And with that, we're going to explore with them three questions. First, how can AI governance frameworks become more inclusive, equitable, and globally representative? Second, what practical steps are needed to translate those principles and policies into real-world implementation while maintaining public trust? And finally, what role should us, scientists, and particularly young scientists, play in shaping the future of AI governance? My hope is that today's discussion moves beyond identifying those challenges and toward identifying opportunities for collaboration, capacity building, and collective action. With that, I would like to introduce first, Emilia Stomena-Dove is a GYA member, associate professor at the Faculty of Electrical Engineering at the University of Ljubljana, and former Minister of Digital Transformation of Slovenia. Her work focuses on digital transformation, interoperability, and the societal impact of emerging technologies. She shares the informal expert group of the Next Generation European Interoperability Framework at DG Digit and is a member of ESER? you tell me later. Advising the European Commission on Research and Innovation Policy. She also shares ALIA's task force on trust in science and serves on the board of Globetics, promoting ethical leadership, responsible governance, and the ethics of AI. Welcome. Next, we have Soribel Felix, fellow Latina from the Dominican Republic. She is the founder and CEO of Personal Algorithms, an AI governance consulting firm based in the United States. Her career spans the U.S. Senate, the Department of Homeland Security, AI Corps, the U.S. State Department, and senior roles at Microsoft and Meta. She holds a CIPP, CIPM, and CIPP. You let us know what are those in a minute. And algorithm auditing certifications, and brings a practitioner's perspective to AI governance, one built from the inside of American institutions across government, technology, and regulated industries. She is the creator of the Algorithms Are Personal framework, which positions AI governance as a lived experience across livelihood, education, community, and policy. Welcome. Last but not least, we have Fadi Dao, laureate of the Elevate Prize for Global Thinkers and Changemakers of 2020. Since 2023 is the executive director of Globetics, 2025 champion of the World Summit on the Information Society. Globetics actually is an international NGO based in Geneva, Switzerland, with regional centers across the continents that promotes ethical leadership and responsible governance for a just, inclusive, and sustainable world. Previously, before Globetics, between 2006 and 2020, he was founding chairperson and CEO of the Adian Foundation based in Lebanon, Iraq, and France, working for diversity management and peace building, and winner of the Niwano Peace Prize of 2018. He recently contributed with Globetics to the launch of the UNESCO Global Civil Society Organizations and Academic Network on AI Ethics and Policy. Welcome. Thank you all. It's a privilege to be here among friends. We're going to start real quick with a 5-minute presentation from Emilia that she's going to talk about the work on the AI policy society interface, one key challenge in AI governance, and one must fix gap, equity, regulation, science integrity, or whatever you want to say.
Thank you so much. Is it okay if I stand? I feel uncomfortable.
Yeah, go for it.
Okay, thank you so much. While we wait for my slides, I have to share with you that this is my second talk in less than 2 months' time that I have a talk after Robert. And this is so unfair because he's such a good speaker. His presentations are so insightful and everybody remembers his presentations and then I come. So next time when I get an invitation for a conference, first I will ask, is Robert speaking? If he is speaking, I'm not accepting the invitation. Thank you so much, Luz. Thank you so much for having me here. So I would like to focus more on the AI governance in the European Union. I'm coming from Slovenia, from the University of Ljubljana, and Luz already mentioned that I've been working with the European Commission a lot. So very shortly, because I only have 5 minutes, I would like to start with this date. It's the 2nd of August in 2026. It's this year, it's less than 2 months. Do you know what this date means? Anybody? European people? AI Act. Yes, it is the date when the rules apply. So the AI Act was adopted 2024, and we had 2 years' time to prepare. But from 2nd of August 2026, core obligations of the AI Act, including high-risk system requirements and transparency duties, begin to apply. So they will be checked, audited, and so on and so on. The rules are here. So in Europe, we cannot say that we are only speaking about abstract governance because we have the AI Act and now the rules are already here. What is the biggest problem that we have? So like Robert, I was also sitting on both sides. I was in the black hole and I'm a scientist still. In the government, I led national and European transformation as a Minister of Digital Transformation. So I was really involved also when not only the AI Act, but also the Interoperability Act was adopted. And I know what does it mean to prepare legislation, regulation like that one. In academia, most of my time, I train engineers who build digital systems. So what are my observations from this? That we are speaking two different languages. The gap between these two worlds is simply too big because in government, you're speaking about principles, you're speaking about frameworks, and then in academia, you don't know what this means. So the biggest challenge that Luz was asking us to address is the translation. In the government, mostly the policymakers, they're speaking about values. They're speaking about the explainability of the system, about non-discrimination, at least they have to. Then about different principles and so on and so on. But when we are speaking about engineers, then we're having in mind specifications. We have in mind errors, logs, we have in mind audits and so on and so on. So if we want to bridge this gap, then we should be literate in both words. I don't say we should be experts in both words, but at least we should be literate. So what is the must-fix gap? Usually when we are in Europe, we say, not only in Europe, also in the States and all around the world, we say, yeah, but regulation is too slow. So technology is always in the front and regulation is chasing the technology. Is this true? So the AI Act was adopted 2024 and the rules apply 2026. But what happened? There is no capacity of the institutions to start implementing the regulation that is already there for more than 2 years now.
So the biggest problem is the capacity of the institutions. We have on one side technology that is running very fast. We have problems governing this technology. Then we have the legal people writing the regulation. And then we have the institutions who should put this in life and they don't have the capacity. And this doesn't happen just like that. It should be thought. So that's why we need standards that are developed together with the regulation, because what usually happens, we develop a regulation and after that, we are looking for the standards. So this is what happened with the AI Act as well. Because we don't have the technical standards, we cannot implement some of the high-risk requirements. Then we need regulators who are skilled regulators, who understand technology as well. So they're not only legal people who understand law, but they need to understand, they need to be literate in technology as well, and to keep pace with the technology. So the biggest question, the biggest challenge that we need to speak about is, can we govern at the speed it actually demands? And again, this is not about writing rules very fast that are chasing the technology, but is the whole system. So we need to have the big picture. We need to work all together. This was very short for the opening, and I would be happy to share more in my panel. And I hope you remembered at least one thing from my talk and not only from Robert's. Thank you.
Thank you so much for that presentation. Soribel, in 5 minutes, can you speak about your work at these interfaces, one key challenge and one must fix gap, whatever you want to add?
Sure. Thank you so much for having me, Luz. My work, what do I do? It's so hard to explain what I do. Like, don't ask me unless you have 5 minutes. But through my company, Personal Algorithms, what I do is I bring the combination of the experiences I've had in big tech, in the government, and in other companies, you know, in the work that I'm doing, and I bring these insights to operationalize AI governance. So similar to what you were saying, you know, you have the regulations, you have the people, and companies need to bring in these regulations and translate it into specifications. So that's exactly what I do. I help companies operationalize AI governance. It's no small feat because, you know, speaking to the challenges of AI governance is that nobody knows what AI governance is. Nobody knows. So the first thing that I do is come to an agreement with the company as to what AI governance is. There's a lot of conflation with AI governance. And I always, you know, I always talk about this. AI governance is not the same thing as AI ethics or as responsible AI. And it's very important when you're working with a company that needs to, for example, comply with the AI Act, that we're not talking here about, you know, equity and marginalized groups and who gets harmed. We're talking about operationalizing the rules so that, you know, those stakeholders, those communities are not harmed. But we can't come in with ethics in mind. We have to come in with a good definition of what AI governance is. And if I can put forward my definition, is an ongoing process of measuring risks and taking steps to mitigate them. That's what AI governance is. And the third question is?
One must fix gap.
One must fix gap. Oh my God, it's so many must fix gaps, right? But, you know, aside from coming to an agreement as to what AI governance is, which is not AI ethics, one must fix gap is to stop putting AI governance as an afterthought, bringing in an AI governance expert, whatever that is, after there's a problem, after there's a threat, after there's a lawsuit that's coming to get you, after there's a regulator that is trying to get into your books. It has to come along with AI adoption. It has to come early, you know, during the product ideation phase. It's a big challenge because nobody's thinking about AI governance. People want to think about adoption, acceleration, cutting costs, efficiency. Only after there is a problem in the horizon do they think about AI governance.
Thank you so much for that. Fadi, talk us about your work, one key challenge and one most fixed gap.
Okay, thank you, Luz. And let me start by saying I'm very glad to be here and thankful for the Global Young Academy for the invitation through my dear friend Emilia. And I feel now I'm speaking after Robert and Emilia and you, so the challenge is growing. I would like to start by going back to the title of our session, which is AI Governance for a Shared Future. And you know that on Monday, a few days from now in Geneva, the AI UN scientific panel will launch their first report. And the key outline of the report, revealing something from the report that was not yet launched, is that AI is one of the most dividing reality in our world today. So talking about a shared future, this means that we are endorsing somehow as a scientific and young scientific community, a challenge that we want to address. It's not a reality. It's the opposite of what we are talking about, because those who are benefiting from this technology today are very far from those who are paying the cost of being marginalized or completely out of this technology. Let's not forget, more than a quarter of the global population is still without any connectivity. So this is, I think, a very, very serious challenge, and I'm very glad to be part of this panel and to share some ideas about it. The second point I would like to make is that AI, when we talk about AI, we are definitely talking about a multidimensional subject. Any subject is multidimensional, but this one more than any other also subject. And let's not forget that it was a scientific subject last century, maybe from the 40s till the end of the century. It's mainly a scientific subject. And then now it's more dominated by the industry, innovations / regulation, governance, and all the questions that comes with. But behind this, there is today, and as a growing factor, the economic and financial factor, all those who are investing in this economy and are having the real say behind this economy and the real say of is this technology will help in building a common future or not, or going in the opposite direction. But it is also social subject, and it is also philosophical or anthropological subject. You know, recently, Demis Hassabis, the founding CEO of Google DeepMind, was at Stanford University in a discussion with the president of the university, and he was saying, now is the time in the AI ecosystem or framework, now is the time for humanities and philosophers to be part of the decision makers in relation to this technology. And that's quite interesting, in fact. But I was last week in Paris, and there were people from those different industries represented. And while I was asking them, and different companies competing with each other, how many people and what is the share of the budget that is invested in those companies for this side of engagement with the technology, humanities, philosophical, and interesting. In fact, there were some of them with philosophy background, psychology background, even theological background. They were in the room representing the companies, but from my perspective, still as a marketing approach rather than as a serious share in reflection and decision making. And so this is my second point I want to make, starting our discussion, that let's look at this topic as a multidimensional one, which requires an interdisciplinary approach. And I'm happy that in this room, I'm sure the room represents very much this interdisciplinary approach to tackle the topic. My last point on this is because it's multidimensional, because it needs to be interdisciplinary too, but it has also to be intersectoral and interregional. So paraphrasing Robert's presentation, so we cannot tackle it from an ivory tower, of course not in a black hole, but also not in a silo approach, you know, not in a Babel tower. So we need a collaboration that is not only interdisciplinary but also interregional. We heard in the first panel the question of global south, global north, global majority, how everybody is contributing to this discussion, and not from a colonialist perspective, but a real global engagement perspective. and also cross-sectoral. And let me end here by saying, so I represent a bit, I think in this panel, the civil society / policy dialogue around this topic, and I'm happy to share more about where we are now about those discussions. Thank you.
Thank you so much. So Soribel mentioned, and I'm not following the script, it's just you mentioned something that I really like, that AI governance is not the same as the ethics, right? And one of the questions that I have for Fadi was precisely about ethics, right? How do you, and any of you can answer this, how do we, from a global ethics perspective, are we moving fast enough to align AI development with ethical principles? What are your thoughts on that? You can say.
It's not only for global ethics question, but if you would like me,
yeah, anybody that wants to start. Yeah.
So
you pick. You can go first.
Okay.
Okay.
so I mean, the easy answer is definitely no, and then I can hand the microphone and see why. But definitely no, because I think there is a fundamental ethical question behind this. It's the mismatch between the ethical agenda, I would say, and who represents this ethical agenda also, which is why for me it has to be intersectoral, really global, really interdisciplinary. And then what drives the technology? Because today and the industry, we are talking about an industry today that has economic, financial factors driving it, but also geopolitical factors driving it. So definitely the gap is huge and it's growing, unfortunately. I mean, I think this is a reality. The second factor that is contributing to this gap is the fragmentation of the governance. We are talking about governance, but we still don't have any real global governance for this and that and technology. And so even if next week we will have in Geneva the UN dialogue on global governance of AI, but we already know that this is just a dialogue and we are not progressing in this. And we were just discussing, even it's not only the lack of willingness from the countries themselves, the governments, to be seriously engaged in a global governance perspective that would include then an ethical dimension and framework, but also, unfortunately, the multilateral system itself that is growingly fragmented and not being able to meaningfully contribute to this. Lots of efforts being done. UNESCO did its recommendations since 2021 and many other initiatives, but still nothing seriously binding and seriously governing what's happening. So this is another also, I think, element, the fragmentation that is contributing to this gap. I do believe that this reality is quite different than others. For example, some compare this with the nuclear energy. And I think it's not comparable because until now, the nuclear energy is mainly dominated by governments. So the owner of the energy is also the regulator somehow, while AI is not at all owned by governments. It's owned by huge now companies that are much more powerful than most of the countries and governments in the world. So if the governments would regulate something that they don't have any control seriously on it beyond the legal framework, I think there is a gap. And then the voice of people. And this is why this is something that needs a very creative way of looking at a government format that it's really multi-stakeholder, that give equal voice to civil society, to government, to industry. One of the leaders of this industry was saying governance is impossible for AI, and the only possible way is to embed an adaptive governance within the systems themselves. So the systems themselves grow and develop themselves in governing themselves, which is meaning that we are completely abandoning any capacity of framing this and governing this technology. So the discussion, I think it's still very, very much on who will regulate this and how it will regulate it. And from my perspective, it's not enough to be governmental. It has to be much more cross-sectoral and multi-stakeholder.
Thank you. You want to add something?
Yeah, definitely agree. But even if we bring it down from the global perspective, from even a country perspective, even in the US, for example, or even in Europe, we still don't have a consensus as to whether we need regulation, as to whether we need an AI policy as to whether AI ethics is just like a woke kind of thing that the leftists are bringing. You know what I mean? Like, we still don't have that. We haven't, as a country in the US, we don't have this agreement that we need to regulate AI. A lot of people still think that if we stop AI, that if we stop and think about ethics, we're going to slow down our winners, our moneymakers, our big tech companies, that we're going to lose to China, that we're going to lose our edge, right? And so even bringing it down.
Thank you.
I have to politely disagree because in Europe we do have an agreement. We have the AI Act. So if you have an act on the European level, it means that all the member states agreed that we need regulation. And democracy is slow. Democracy is expensive. Autocracy is very quick. But do we want autocracy? So democracy has a price, but for a reason, because we still want to respect fundamental human rights. And this is why we need regulation. So if this is the price we need to pay for it, then I'm in.
Okay. Somebody else wants.
Well, I was just going to say that. Yes, there is the EU AI Act, but you do know that there's a lot of companies that were up in arms against it, and there were a lot of people that were, think that Europe is behind and the EU is behind, and that by bringing in this regulation before the technology actually takes shape, that Europe is shooting itself in the foot. There is quite a bit of disagreement with the EU AI Act, and there has been some modifications to accommodate companies, industry. So yes, we do have it. You do have it. And I think the EU AI Act is a great piece of legislation. But to say that there was 100% consensus, which is impossible, but there was disagreement with the EU AI Act. I'm very glad that the EU stood its ground and that is still there. But again, like, there is no agreement, like there's no 100% consensus. That's what I was saying.
Of course.
Okay, just a quick comment, because I think, and from an ethics perspective, also from global ethics perspective, it's not enough to have regulations. Even we are discussing the regulation, but even if we have the best regulation, it will not be enough. Because to give you an example, I think that is quite comparable. The harm that we did to the environment, most of it was compliant with regulations, and we destroyed our environment and ecosystem.
Yeah.
So it's not enough. I mean, if we have the best regulation, this will keep allowing companies to invest and go into directions that are less risky for them and too risky for the people or for the world or whatever. So this is why with regulation we need ethics, and I feel that one of the big risks that we are witnessing these days, that if we concentrate all the discussion on regulation, we somehow de-responsibilize the leaders who are taking decisions from their ethical also responsibility. Because you can take a decision and say, that was compliant, and then it led to a catastrophe in the world. And this is not, I mean, even if it's compliant, but it's not acceptable. So this is why I think this question of the real difference between ethics and compliance needs to also to be part of the agenda, and to bring also to the discussion the accountability, not only from a legal perspective, but also from personal responsibility as an ethical responsibility. It's much more difficult to do it because you don't have the legal or institutional framework for it. But I think what makes us a human being also is our conscience and our responsibility, and and on the corporate level also the global responsibility of corporation or social responsibility needs to be a big part of the agenda.
Thank you so much for that. Love the discussion. So this question was posed for Soribel, but we're talking, we're all talking about the same topics. What are the biggest blind spots that any of you are seeing in the current frameworks, AI governance frameworks, when it comes to marginalized communities or communities that are not as represented as others?
Okay, so the first thing is absolutely when we are speaking about AI governance as general, not only marginalized communities, we have in mind that the data governance is already there. It's not. Data governance is not there. So again, we have the regulation. We might be compliant with the Data Act in Europe or the Data Governance Act, but as Fadi was mentioning, regulation is not enough. So what data are we using? Who is preparing the models? Do we have enough data of the marginalized communities? We don't. And we have seen this in the past as well, even before artificial intelligence. So if we want to have everybody on board, then we need also the data from everybody. And Fadi just mentioned 1/4 of the world population doesn't have access to the internet. It doesn't mean that they're not only connected, but it means that we don't know anything about them. We don't have their data. So how can we include them if they're excluded from the connectivity, from the basics?
Yeah, I would say there's quite a few, right? But when thinking about governance frameworks, we think a lot about the model. Is it fair? Is it unbiased? Is it accurate? And then we tend to see this communities, right? Like the models and the effect on the communities in a snapshot. Like at this time, at this moment, okay, it is fair enough, it is accurate enough. But the thing is that AI models are very much, you don't see it all at the same time, right? So you have to, instead of just looking at it as a snapshot, you have to look at it over time. How does it affect and impact communities over time? One impact assessment before you even deploy it is not enough. You have to look at the cumulative effect of the model. You have to look at the indirect harms, right? So for example, if you have a model that, this is very US-centric, but denies employment, so excludes someone from an interview that could have changed someone's life, then what are the effects to that? So I have no employment, then I can't buy a car, then I can't get health insurance, then I can't do this. And then that one effect had, such consequences and consequential effects and secondary effects on the person. And we don't capture that by just looking at, is this fair? Is this unbiased in one snapshot? So that's, those are indirect harms that a person really can't grasp. Oh, wow, one AI decision, one algorithmic decision had this impact in my life. And then another one is that we assume that everyone has this literacy, like this AI literacy, this digital literacy. A lot of people don't even know that the decisions that impact their lives are being made by an algorithm, and that there's absolutely no transparency behind it. There's no, if you went to look at what's inside, all you find is a black box, and you don't know what the hell went into this algorithm, right? And so there's so many blind spots, but I'll stop there.
Fabi.
I'm thinking about one blind spot, and I had so many in my mind, so I'm struggling to choose one of them. I would like to say one of the blind spots, maybe that it's interesting to look at, is that the technology itself can be part of the solution, in the sense that, yes, there is this gap that is even growing because of those big companies with big investment, and this geopolitical race between two giants, US and China, and so on, power-based related to this technology. But at the same time, this is a technology also that is very accessible if you have a minimum of infrastructure and a minimum of capacity, that maybe using it in this perspective can be part of the solution, fixing the problem. I won't to give a very concrete example, we recently launched at Globe Ethics a fellowship for emerging leader on ethical AI and governance AI. We had 15 seats, 15 positions for this. We received 1,660 applications.
Wow.
And it was so difficult, to say no at all those 1,660 applications, because behind it, and this is also our young, applicants and leaders, there are amazing projects coming from all over the world, from countries even you don't think about it. And then we had to select 15, and we selected 15, and we will welcome them next week in Geneva. And they are having mentors, and so they will be trained. They are mentors and other access to other opportunities. One of those fellows that I'm mentoring, just to give a concrete example how the technology itself might be also part of the solution, she's from Pakistan. She's a young lady from Pakistan. She's using AI to work on decreasing the discrimination against children of minority communities in Pakistan. I'm sure no one here in the room would think that AI can be a solution for such a social problem, persecution of discrimination of children in minority communities in a country. And she found that AI, and this lady, she's an expert in human rights, part of Human Rights Commission and work. So I'm giving this example to move maybe to a more positive side of the discussion, saying the technology itself might help in solving some problems. But let me add one final thing, and we, I think, need also to discuss in a scientific community that there is a risk that comes with this, and it was mentioned many times this morning, that we become tempted by looking at reality only as a data-based reality, as a digital reality. And then we have quarter of the global population excluded. We have a huge amount of knowledge that is not there and it's excluded. And this is a very serious, I think, challenge that we need to take into consideration, because behind it, it has economic problems. It was mentioned in the morning, the funding issue. How many of us as scientists, people also would be very much tempted to work on data as a source of knowledge and the only source of knowledge, because it's much more affordable and accessible, and you can get faster results. In the also competition in the academic world, than having to travel and do a field research, in a remote area in the world, and you need grants and fundings to be able to do this, to bring the knowledge and the realities that is there. So this is another, I think, challenge. We need to look at it, and especially related to the funding issue. Thank you.
Yes. Something I want to add from this conversation, I personally been affected by this. As you know, I was terminated from the federal government, as you might know, from the State Department. And I've been applying to so many jobs and fellowships. And sometimes I feel like the application goes into a black box. And most of these times because the algorithms and the cutoffs of these systems, of these AI systems, that they're losing people like me, like people like all these federal employees that were fired without justification. So I sympathize with everything that you're saying. And I think in the US, we're seeing that firsthand right now. At this moment. So thank you for bringing that, because that's personally affecting me and a lot of people. Okay. Going back to Milia, I love your presentation because you answer most of the questions that I had. But let's talk about interoperability, because I mentioned it in my remarks. It's a key pillar of digital governance in Europe, right? How does it shape the way AI systems are developed, deployed, and governed across countries?
Thank you so much. So this is the topic. I can speak for ages, but I won't. I promise. Interoperability is something very abstract. It's something that many people have challenges even pronouncing it. It's a difficult world and nobody really understands. We are all speaking, we need interoperability, but we don't really know what interoperability is. So when I try to explain interoperability, I use Lego as well, Robert. So, we are, as children, and now our children, for most of them, they always play with Lego. But why? What makes Lego so special?
it's not the boxes, it's not the plastic box, but it's the connectors. The connectors are the one that make this plastic possible to create. So Robert had, it is design, and now we have for design and development, and with AI, because our systems are connected, we can have design, development, and innovation. So for me, interoperability are the connectors of the Lego. If we don't have interoperability, we cannot, even if we have all the data out there, if we have all the systems out there, we cannot develop and we cannot create. So we cannot speak about artificial intelligence without interoperability. We cannot speak about digital single market. We cannot speak about collaboration without interoperability. So luckily in Europe, again, we have the Interoperable Europe Act and so on and so on. And now finally, we're introducing the digital wallet, meaning that we can have also public services that can be used even if I'm Slovenia, if I go to Netherlands, if I come to Germany, if I go to, I don't know, Croatia, I can use their public services. So this is very important. Another thing we usually don't understand when we speak about interoperability, the first things that comes to our minds is the technical interoperability. And when we are speaking about interoperability in Europe, we speak about technical, semantical, legal, and organizational. So Fadi was speaking about fragmentization of different regulation. And this is a big, big issue. So we have on different levels, we have regional, national rules, we have European rules, and so on and so on. And they're not interoperable. A lot of times they're in contradiction to each other. So that's why we also need legal interoperability. And very important thing that is the biggest challenge when we are speaking about interoperability and why this system doesn't work is the organizational interoperability. We tried with our team of experts to provide the next generation European interoperability. It will be published early next year. So we hope that after that, we will have the grounds, the basis, the substrate on which also we can adopt AI more efficiently in Europe as well, not only on the corporate level, but also on the governmental level.
Thank you so much. Fadi, you want to add something else or you're good? Okay. Before we go, we have an activity for you. So you're not listening to us all the time. I would like to ask you, where is that question? Where is it? What, from your perspective, your experience, what does inclusion actually look like in governance? Beyond, we talk about marginalized communities, we talk about algorithms, we talk about so many issues. But what would you do differently to create this a more inclusive environment from all that we discussed?
That's a great question. I think this conference is a good first step, right? Bringing people from all over the world to having these conversations. I'm very big, and if you follow me, you know that I'm very passionate about this. I'm very, very passionate about having, I don't want to say this word, but I'm going to say it, diversity of everything. And when I say that, I mean it in a way that is, so for example, in the US, I see it as diversity of geography, because a lot of the AI conversations are had in the coastal areas of the US, whether it's Silicon Valley or New York or Washington, D.C., which I live in Washington, D.C., so I'm part of that. But there's almost no real conversations or activities happening anywhere else, in the Midwest, in the South. So I think that's one thing. So the diversity of geography, also intergenerational diversity, in terms of this AI game is skewed to the young, right? It's very much young people, and I think we're leaving behind quite a bit of talent and insight and perspective from older people, Generation X, people that have been through this before, people that have been through hype cycles and bust cycles, and they can bring so many interesting perspectives if they went through, let's say, the dot-com boom or the Great Recession, or all these booms of technologies. Also, I see a lot of concentration not only in the cities, but also in academic institutions, right? The elite academic institutions, Ivy Leagues, the MITs, the Stanford. In Europe, you have Brussels and the Oxfords out there, but we almost have no investment in like the smaller institutions that teach and that educate 90% of the students. And so I see a lot of insularity in the AI space, geographic, very elite, very like upper middle class, very young. And I think that's a mistake. And we're losing a lot of insight, interest, and perspective by not bringing in this other people, especially people from the global South. So to me, inclusivity means not just like having international conferences and global conferences like this, but even in our own countries, when you go back to your own countries, look at who's dominating the conversation. Who is, what institutions are included? What ages are included? If you see a room where it's just people like you, then your own country is not doing a good job of being inclusive when it comes to AI.
Thank you so much. I think Soribel already started speaking about conferences. When we're speaking about inclusivity, it's like have your say. We will invite people from all over the world, from all ages. So like ticking boxes, America, Africa, Asia, we have them, old, young, marginalized companies. And then people come first, have your say, but do they? Do we let them have their say? And even if they do, are we listening really to them? So this is the biggest problem. We're asking them, they put some effort, they prepare statements, opinions, and so on, but we do our business as usual. Yeah. So what is really missing is the listening part. And then, of course, to include that. So in the previous panel, it was mentioned, let's stop speaking about inclusivity, but about expansion. And I would say, let's stop about asking people to speak, but let's start listening to each other. It might help.
To add a quick additional point on this, we need to have a space for everyone. So in addition to diversity, it's dialogue spaces for dialogue, but dialogue in the sense of first, listening. Excuse me. The consequences of the heat wave, listening also to each other. But to add to this, it's the empowerment. We need also to empower people when they are part of the dialogue space or engagement space. One of the sociologists in the 50s or last centuries were talking about the human rights and saying freedom of expression loses its meaning if I'm not empowered and educated to know what are my rights and how can I express them. Exactly. So this is, I think, it's the same dynamic happening here. It's not enough to have people like checking the boxes, all colors or regions or generations and so on. It's also what are we doing to empower those people to come with something that they can engage in a meaningful and powerful way in the discussion. And this is, I think, a crucial point also for the scientific community, thinking that, okay, collaboration, maybe across continent, across regions, it's very important, but collaboration based also on mutualizations of resources, of knowledge, to make people also capable to contribute on equal footing and in a meaningful way.
Thank you so much. Love all those answers. So we're going to have a live polling that we're going to have in 1 second. Talking about inclusivity, we want to hear your opinion. So if you please scan the QR code and put this code over there. and both. The question is, what is the biggest challenge facing AI governance today, in your opinion? Ensuring equity and inclusion across regions, building public trust in AI systems, translating principles into practice, preventing concentration of power among a few actors. I like that one. Balancing innovation and regulation, or other. And for those of you that mark other, please specify. I'll give you the microphone. I'll give you a couple of... Oh, can we maybe move it a little bit so we can see all the results? Like, scroll. Cannot be scroll. What?
My vote is winning until now.
Perfect. Thank you. Yeah. Wow. Looks like the first one is winning. Oh, no. Okay. I'll give you 1 more minute to vote. Okay. It looks like we have a winner for now, right? Which is what we thought, preventing concentration of power among a few actors. Do you have something to react or say about that?
I'm not surprised, really. This was also my choice. But Fadi was already speaking about that, comparing with nuclear energy. So the real problem here is that these few actors are not governments anymore, but these few actors are big tech corporates. So these are people who can do whatever they want. It was mentioned Starlink. So somebody can just decide and cut off you everything. So, and we're speaking about AI, somebody did decide that we are not allowed to use Fable anymore for Anthropic. From today on, we can again use it. So it was a new decision. But you see how these things happen. So we're all dependent on them. And as a researchers, we have our infrastructure dependent on corporates, we have our data dependent on corporates and everything, and we're not even considering, we're just users. We became dependable users. So this is what really, really scares me. And that's why in the previous session, when we were speaking about public good, I'm a huge supporter that AI models should be a public good as well. I know that the companies don't agree with me, but I just as the Pythagoras theorem, these are things that influence people's life, that influence our societies, that influence the planet we live on. And that's why, and they were built on public knowledge and funded with public money.
Yes.
And that's why they have to be public.
Yes. Somebody else wants to say something?
I'm happy to say that I voted also for the same. But I have a different also concern in relation to this. The main concern is that this concentration of power in the hands of few people who are not at all accountable to anyone. They're accountable to the shareholders and even. This is a serious problem. But for me, there is another problem behind that is maybe more serious, is that those people themselves, they are saying that they are losing power on technology. So this is also for me, it's a serious concern, even though it's still now like part of the media discussion and maybe not enough as a serious scientific and policy discussion. But when we hear the head of those companies saying that we are at very few years of AGI and general intelligence or super intelligence, whatever, and we are witnessing signs also of losing any type of control on the technology itself, and they just announce this without like a serious concern of how we manage this reality, beyond going to parliaments or Congress and saying, oh, hey, government, this is your role to tell us what to do, or calling the philosophers or humanity people, come and help us what type of decision we take. That's good already, that there is this awareness that it's not anymore a decision that should be left in the hands of a few CEOs. But what are we doing concretely to think about a serious issue too?
Thank you.
I would just add, my choice is not, it's not there at all.
No?
It's
Which
other,
one?
right? Because these are all like pre this, pre that. But my concern is post, like accountability. Because even if it were a public good, right? Even if we built public trust, we ensure equity, but if someone was affected by it, what is the accountability? What recourse do they have? How can they redress grievances other than a lawsuit, right? And right now, everything is decided by a lawsuit, by courts. Lawsuits are expensive, slow, and not everyone has the digital literacy or the resources to go against a big company, or the bravery or the courage, right? And so there's no easy way to have recourse, to have like the Bill of Rights, right? There's redress of grievances. People have revolted because they have no recourse. And so without recourse, like we can have all of this. We can have it as a public good. But even if it were a public good, still a governmental thing, right? And it's still like no recourse, no way to hold the system accountable.
Thank you so much. Well, we want to give some time for questions. We have 15 minutes. Oh, I love it. Who's helping us with the microphone, please? I love all the questions. And if you could please briefly introduce yourself first and then ask your question. So, yeah.
Hello, I'm Oscar from Mexico, member of the Global Young Academy. And speaking on accountability, taking on that topic, and also on the previous mention of, like you mentioned, Amelia, we need your data to include it. But then what about the people that don't want their data to be included? Like, for example, indigenous people that have had a history of people coming to help and then profiting of that interaction and then getting nothing in return. So there are people that want to not participate in that process, and they have like an AI, but not artificial intelligence, but ancestral intelligence that they want to keep protected and continue their culture. So what happens when the regulations that are put into place, like in many parts of the world, are used or enforced only when those in power deem that they want to do it, but when it's to protect the vulnerable, they don't apply? Thanks.
I will make a round of 3 or 4 questions.
Okay. Yeah. Thanks. So I'm Francesco Maurelli, GYA Executive Committee. I realize how hard it is to be rejected by an algorithm, but I don't see a huge difference than being rejected by a human. So at the end, when we apply, if in the past there was no AI system, we wouldn't really get much back. It will still be sending things in a black hole, not really receiving anything. So sometimes we redirect our anger or our frustration because we weren't successful in that case towards technology, but maybe the technology is not the issue. Yeah.
Hi, I'm Rita Okorafo from Nigeria, working in USA. So I want to go to that comment on interoperability. It's really kind of complex to pronounce. So on August 2nd, we're going to have the rules that will be implemented. to what extent does it address any or all of the different layers of whatever that word is? It's a tongue twister. And I think that it is something that kind of hinges a little bit on inclusivity somehow. To how long do we see us being able to address all of the different layers of interoperability? Yeah, that's the question I have. Thank you.
So, who wants to answer the first one about from Oscar, or you want to combine?
I can shortly combine the whole three. So, Oscar, I agree with you, but this is a choice. So it's a choice if you want to be included or not. You decide on that. I mean, if you, we are speaking first, if you don't want to be, I was speaking about the people who don't have the opportunity because the infrastructure is not there. And if you say, I'm out of it, leave me alone, then I think it should be a personal choice. If I am a decision maker, this is definitely, I don't want to expose to anyone to do something that he or she doesn't want to do. And it's different if you decide not to be included or it is not possible to be included. So I make a difference here. Then the second questions, Francesco, I agree with you, but you know, the artificial intelligence wasn't written, the models wasn't written, or most of it, by artificial intelligence yet. So they were written by human. And you're just reflecting everything in the artificial intelligence, the algorithm that you're preparing as well. So, and then the interoperability, it is an excellent question, and I would love to talk with you. And we did a huge change. So I'm sharing something that is coming up next year, but still I'm speaking about conferences here. We tried to provide 6 very basic principles, and we said, okay, these are the principles we need to follow. Openness, transparency, I don't know, everything. Then we took a look, because this is about policy making, about service design in public administration. We put 4 most common scenarios, and we provided recommendations. We were not dealing with particular technologies because it's impossible. You know, these technologies are changing so fast, you can simply not follow that. But we said, when we are developing public services, even if they're not digital, they need to follow this principle, transparency, accountability that we were speaking. So we said, these are the basic principles. These are the scenarios that are most common scenarios. These are the stakeholders that are included. Then we provided some use cases and some recommendations, who should do what, who is responsible for what, who is accountable for what, and so on and so on. And this is just like not an excuse for someone or taking the responsibility for the policymakers, but just giving them something concrete, something like guidelines to help them.
You want to?
On the first one, I would say I agree with you, and I hope that this, you know, the indigenous people that have been historically harmed, that if they want to be left alone, that they have that option, that they are left alone, and that we don't impose anything on them. And to Francesco's question about accountability, I would say a human can get fired. So if a doctor makes a wrong decision, they can lose their license. If a lawyer makes, you know, a wrong or commits some kind of ethical breach, they can lose their license. A human can suffer consequences, an algorithm can't.
Exactly.
And, you know, when we're talking about human working with AI, with an algorithm, the human is still accountable. And so my hope is that when that becomes widespread, that you are working with algorithms, that not only is the human accountable, but also empowered. So if a doctor is working with an algorithm and for some reason, like it's happening now, they are more reliant on the algorithm, whether because they want to or because they're being forced to, that they're also empowered to shut down the algorithm and override the algorithm and make their own decisions with human judgment. So that is my hope. But a human is still accountable and can suffer serious professional consequences if they make a mistake.
Can we get 3 more, right? 3 more?
Thank you. This is Laura Zimmerman, GYA member from the United States. And I'm an economist and political scientist by training. And so one of the things that I find very interesting here, so I clicked other on the long list here, partly because I think some of these categories here are themselves symptoms of a broader underlying issue, which is that when we talk about AI governance, we don't have all the people who work on the governance part, I think maybe as integrated into the process as would be helpful. Right? So economists, political scientists, we study governance, we study incentives, right? A lot of this is about, are the incentives aligned with the broader good? How can we get people to do things they may not want to do, right, if left to their own devices, but how can we integrate that into a better system? And so I wonder whether the challenge is that it's hard to involve social scientists at different parts of the process. I really like the idea Soribel brought up about the post process, right? So once the system is in place, once we see how it's working, is that when we should bring in social scientists more heavily, or should they? Or is the challenge more of a communication issue? Social science, by its very nature, I experience this every day in interdisciplinary social science work, is messy. We don't have as clear of a voice, not as clear maybe of a truth, if you want to call it that way, as some other disciplines do. And that can be a problem, but I think that can also be a strength, because a lot of social science, sociology, social work, for example, is very, very heavily context specific and really prescribing, okay, we need to find the best thing for each specific situation rather than point blank ideas. So just curious with your experience, what the panel thinks of that.
Thank you. My name is Tariq Khan. I'm a GYA member. I want to build on what Amelia said there at the last. On June 12, the United States government blocked Anthropic's Mythos and Fable for foreign nationals, access to foreign nationals, which was allowed last night, and it will be available this morning. So you said we need to prevent concentration of power among the companies. What about the fact that a nation, a government can control frontier AI models, and they allow access to other nations only if they want to?
Hi, my name is Branislav. I come from Serbia and Argentina, I would say. So, working as an analyst in international affairs, especially focused on AI governance and humanitarian, let's say, settings and crises, we can see that many discussions on AI governance focus on regulations, interoperability, while the geopolitical asymmetries behind who develops strategies, data sets, and evaluation frameworks are becoming increasingly, I would say, important. And these asymmetries also affect the scientific and technological sovereignty of countries with especially very limited capacities. And I mean, you also mentioned the concentration of power among very few actors and the need for accountability. So my question is, drawing on your experience, how can the international community or maybe Global Young Academy or scientists promote all that interoperability without making it another form of dependency? Thank you.
One more, if you, I think there were, yeah.
Thank you. Christian Nkanga. I'm coming from the Democratic Republic of the Congo and the US. I wanted to stretch out a little bit and go back to the issue of data governance, because AI has got multiple components and the data is just one of the most important ones. With the concept of garbage in, garbage out. So the AI requires you to actually keep up to date with the data, with how this world is going on and the situation. The heat wave, for example, is just a perfect example of how data is changing, situation changing. So if you look at the data, the way the AI operates, where you need access to the body of knowledge, which is a global situation, you look at the journal articles, the way they are set up, some are open access, some are not. And if you talk to technical experts, they would say that AI is able to sneak in some journals, but it requires some sort of formatting for them to, for the algorithms to be able to sneak in. But the question is, how can we regulate the data quality and data access for just enhancing the performance and effectiveness of the AI? I would think of local government and national level people can come up with some strategy to come off, afford open access for institutions, etc. But what is that we can do at global level? Because this is something that we cannot really handle locally. It's something that perhaps in national organizations like GYA or ISA, but I don't know. What is that? So the question is, how might we regulate data quality and data access for the sake of AI in terms of performance and effectiveness? Thank you.
Yeah, I was asking, can we, no, it's just we have the conference photo afterwards. Yeah, because we start 10 minutes late, but.
I'm just wondering, quickly, okay, AI is advancing very fast, faster than most regulations. And I wonder, what can we do, as scientists to kind of bridge that gap, and somehow translate our knowledge to decision makers, so that these the new technological developments are known, so that the new policies can be developed on time and not as in a reactive way. Thank you.
I can answer this question quickly based on the small experience we did with some parliamentarians. There is something called the Inter-Parliamentary Union, which is an international organization also similar to the part of the multilateral system, but not government-based, parliamentary diplomacy-based. And we did a small experience with them, and I hope that this will continue, is capacity building. Because those who have the mandate to take the decisions on those questions, they need capacity building because they don't know what are the challenges, how to deal with these challenges. And this is why I insisted at the beginning on the multi-stakeholder approach, because regulating AI needs also the scientists to be in the parliaments, not just the lawmakers, and so this type of engagement is absolutely important these days. So I would say we should further develop this multi-stakeholder collaboration, scientists, civil society, governments, and also private sector together in a much more frequent way, and less those global dialogues with 5,000 people in the room, but smaller national-based dialogues, hearings in parliament, initiatives in universities, engaging all those stakeholders together to become better prepared to engage in this area.
I'll answer that question and the economist, political scientist question at the same time. And I'm going to say something unconventional, but I would say two things: go local and go global. So, following up on building on what you said, Fadi, about capacity building, is you have a constituency, which is your local, people that are next to you, right? Your friends, your local government, community, whoever you have next to you. Why don't you, I think there's power in starting to talk to people that in ways that they understand. So a lot of the literature when it comes to economics, when it comes to political science, is in, scientists. It's very thick, very dense. But what if you could break it down into simpler terms and share it both with your communities, but also share it in social media. Share it with the world. And policymakers are humans too, right? We're all losing our attention skills, our attention span. So I think academia has to come to terms with what's happening with humans, right? We need things broken down in simple terms and in quick bites. So I think we should use that to our advantage. So use it to your advantage. If you have something like Jevons paradox, break it down. Tell people what it means in simple terms. Take advantage of social media. I think social media is great. I think it's doing things to us, but we can also leverage it and use it to our advantage. So I think those are the best two ways of doing it, in my opinion.
I would like to focus on the sovereignty questions from that side. So remember now my question earlier after the first panel when I was asking, the panel was global collaboration, and 2 hours later, we're already speaking about data sovereignty. So yes, it is an illusion. We all want global collaboration, but then we have a lot of different frameworks and networks and so on that it's simply not possible. So what can we do about that? First, try to empower people to understand, to empower not only policymakers, but everybody, and to understand what are the implications of something. For example, what is the implication of data governance? What is the implication of using artificial intelligence? But also trying to explain them what are the implications of not having that there. The best way to convince somebody to start using interoperable solutions is to show them the cost of using non-interoperable solutions. It will, trust me, you will convince them much, much sooner than just saying interoperability is fine, interoperability is cool. Let them, give them the cost there. So empower the people, talk to the people, engage, go talk to the politicians. They're humans. Of course, they're humans. Many of us were being involved in politics, and politicians need evidence. They need arguments. Robert earlier mentioned, you go into the parliament. If you go in the parliament, you want to be equipped. For me, the parliament was the scariest place in the whole country, because you're constantly ask questions, and it's good if you have evidence, if you believe if something, if you want to convince them. Not all the politicians are like that, but many of them are. So do your best, try, approach them, send them an email, not only social media. You will be surprised how many of them respond. Almost the same day. So yeah, empower people and try them to understand.
Thank you so much. I love the enthusiasm and all your questions. They're going to be around, right, for a little while. So if you have any other questions, I know we didn't have time to get to all of them. But going really quick before we close, going back to your point about reaching out to policymakers, that's a big part of what I do. And the reason also that I met Soribel was through a fellowship, a capacity building fellowship that trains scientists in how to do that and how to translate that science into policymaking, into evidence-informed policymaking, which is the AAA Science and Technology Policy Fellowship. And there are other fellowships available, and I'm a huge advocate for scientists like you to start getting your feet wet with this capacity building, how we translate that science, because we need your voices. We need your voices, and it's important that you know how to communicate and translate that to create impact. So thank you so much for our esteemed panelists. I enjoyed this very much, and for your engagement, I love it. And yeah, we are gonna take the conference photo in a second, right?
Yes.
Thank you so much.
Before a big round of applause. And a small gift for our panel as well, please. And there is some wrapping paper and bubbles on the back of the room, so maybe during the lunchtime we can sort it for you. So now, very important, the most important part of the program for today, no, the second most important after the panel, of course, is the picture, the conference picture. So we're going to be in a very special place. There is our graduation picture place. So be ready with all your graduation hat to launch in the air. So we're going to exit from the side on the outdoor doors. We're going to walk just 30 seconds and we're going to be on some stairs so that we can make sure that we can take everyone in the picture. And after that, we have lunch in this building upstairs. In this building upstairs, yes. Lunch is in this building after the picture. The picture is for everybody. Everybody, please come up outside. Test, test. Test, test.
And the biggest distributor. Like put it on a tripod for the signal on TV. On the TV. Yeah. Just talk. You can see it. No, if you need it. Yeah, but during the time when we discussed the line, the meeting, everybody said, "Oh, you're not discussing." And then over there, so you're online. Like also be. I mean, yeah, it's
One, two, 1, 2, 1, 2, 2, 1. 1, 2, 1, 2, 1, 2, 2, 1. 2, 1, 2, 1, 2, 2, 1. 2, 1, 2, 1, 2, 2, 1. 2,
Kirsten, can you hear me? Kirsten, can you hear me? Can you hear me? Kirsten, can you hear me? Yes? Okay. Can you hear me? Yes? Okay. Can you hear me? Yes? Okay. There is a delay. Oh my God. There is a delay. Oh my God. There is a delay. Like an echo. Or maybe because I had YouTube opened. Now I closed. And can you read my message in the chat? Yes? Okay. If you are writing me, I can't see it. It doesn't appear if you're writing me. I can't read your message in the chat. There is a messages can't be synchronized to this meeting chat due to settings or some participants Zoom workplace app
Der ist der Entscheidende. 1, 1, 1, 1, 2. 1, 1, 1. Okay. Also, bei uns alles okay. So. Okay, ist perfekt. Ist perfekt. Das sind wir. Das ist unser YouTube-Stream.
So we can't leave this open.
The gong was done. Yeah. Okay. Sounds good. Good afternoon, everyone. No, I'm not a panelist or moderator again. I'm just here to introduce our distinguished moderator for panel 2, Accelerating Discovery, AI's Transformative Role in Natural Science and Engineering. So the moderator is going to be our very own Francesco, our host. Francesco Maurelli is a GYA Executive Committee member, professor in marine systems and robotics at Constructor University in Bremen, here, where he also serves as program chair for the Robotics and Intelligent Systems program. He has obtained his PhD at the Ocean Systems Lab, Heriot-Watt University in Edinburgh, Scotland. He has been scientific manager at Technical University of Munich, where he led European-wide initiatives to support moving robotics technology from the lab to the market. After a research stay at Massachusetts Institute of Technology in Cambridge, Massachusetts, USA, as a Marie Curie Fellow, he has accepted a faculty position in Jacobs University, Bremen, currently Constructor University. Welcome. Thank you.
Thank you, Luz, for the kind introduction. And I know that after lunch, we are all a little bit interested in science. And we will try to make the session as interactive as we can with our great panelists. But before calling the panelists, I want to give a short introduction. Well, first about myself, so you know why I'm moderating this session, about the topic. And then we're going to have an introduction from all of the panelists. So I'm the program chair for the Robotics Intelligent Systems program here in Constructor University. So welcome again to my place. My office is actually over there. But we train not only engineers. So people were asking, why are we having a panel about machine intelligence in natural science and engineering? Usually, I mean, also in the university, we have a school of science and we have a school of computer science and engineering. Why we have a panel together? Well, because these people need to talk. Too often we hear from scientists that, oh, I don't do AI, I don't need AI, this is for computer scientists. That is changing, this is not the truth anymore. AI is changing every single aspect of science and education. And actually in my work, I have co-supervised students as well in many different fields. That's why we decided that it's interesting to have a mix. And this mix is interesting also because if you think about robotics, AI, of course, it's a science on its own, but then you need to apply somewhere. And we would see different kind of applications from our panelists. They are very different, very interesting. And on the bottom, you can see a few of my friends. Of course, after all my GYA friends. I work in robotics, so a lot of marine underwater robots, autonomous driving. This was the DARPA Urban Challenge 20 years ago. So now in Constructor, we do autonomous racing. So it's autonomous Formula One style car, very different from 20 years ago at the very start of autonomous driving. Up to Sky project with the European Space Agency and so on. I want to start with a recent paper from Nature that was published in May 26, so just a month ago. So we have now a multi-agent AI system that can run part of the exploration, part of the discovery, and get to results. So it was considered one of the kind of new kind of papers where instead of having humans having an hypothesis and then doing the experiments in the lab and getting the results, you are trying to get the AI system by itself to generate an hypothesis and to test the hypothesis and to get to the results with very minimal human intervention. That's great, creates very interesting questions for our panel later. And I want to start with this one because this is actually also very much linked to some of the activities we do here in Constructor. So we are in Constructor University, and we are part of the much larger Constructor group. And one of the products that they are developing is actually Constructor Hypothesis. That is AI system to develop, generate hypotheses from the current knowledge that we have. And then you can iterate with the system and so on. So are they new tool for scientists or are they substituting scientists? I think this is an interesting question. And now I think it's the time to introduce our great panel. So we have Liz Ovreas. So please come on stage, President of the European Academies of Science Advisory Council. Dominic Grimm, he's professor for bioinformatics at TUM campus in Straubing and the University of Applied Sciences. A big round of applause for Dominic. We have actually not here, but here with us, but virtually, we have Maddalena Rostagno, that is a leader of a task group of artificial intelligence for material design. So unfortunately, due to different flight cancellation and trains problems, she's not able to be here physically, but she is with us remotely. So please give us a round of applause for Maddalena. So you would see the slides on the screen and Maddalena on the other screen. And our own Rishmit Kaur, please come on stage. Senior Principal Scientist, Central Scientific Instrument Organization. And she is a new GYA member. I think this also shows the breadth and width of GYA participation. We had past co-chairs running the Science Leadership Workshop, running the opening panel, incoming member now in the panel. So it's full of bright talent. So a round of applause for all the panel. And let's start with a round of introduction. Maybe I'll pass the word to Liz. While the presentation will come on stage, I give you another example of why AI is actually linked to all other fields. One of a student project that I had was in computer vision. I mean, computer vision can be applied to lots of different things, but me as a computer scientist, as a robotics engineer, I need an application domain. And a colleague of mine, a cell biologist, Professor Claudia Briggs here in the university, was trying to understand the cilia of cells. And we were trying to collaborate together with a student that was majoring computer science with a minor in cell biology, how we can recognize the cilia of the cells with computer vision techniques. So Liz, the floor is yours.
Okay, thank you so much. And thank you so much for the invitation. So my name is Liz Ovreas, and I'm the president of European Academy of Science Advisory Council. And I'm also a professor in microbial ecology at University of Bergen, Norway. I will give a little presentation of ESAC. How many in the room knows what ESAC is, have heard about ESAC? Okay, a few of you, that's good. But I still think it's nice to know what ESAC is and how we're working, and also how this is reflecting on the topic that we are discussing today. So ESAC is the European Academy Science Advisory Council. It was founded in 2001, so we have 25 years anniversary this year. And this is a mechanism for mobilizing Europe's best scientific minds on public policy issues. So that's the main message. And we are providing science-based advice on issues of importance to European policymakers and the civil society. So we are building expertise on scientific excellence, independence, and impartiality, free from political or economical interests. So we are very independent in that sense. We are a total of 29 member academies, and at the moment, the Austrian Academy is the host academy. So the academies are 25 national academies of Europe member states, in addition to the national academies of Norway, Switzerland, and UK. We also, the member, the Academia Europea, the Pan-European Academy, is also a member of ESAC. We are also collaborating with ALEA and FIM, and so they have a status as collaborating network. And we are also regional. We are the regional network partner of Inter-Academy Partnership that we also heard about earlier today. So that's the how we are organized. The objective of ESAC is to have a comprehensive assessing the pressing scientific and societal questions solely based on scientific advice. We want by this to assemble the good minds in Europe and also to enhance the European policy development and implementation by conveying knowledge and give advice. So we focus on 3 different topics. It's the environment, the energy, and the bioscience, science and public health. So this is natural science topics, but we see the last couple of years, these panels is working very interdisciplinary. So we have a lot of humanities and social science and economy also inside this working group. This is a solely bottom-up process that we are doing in ESAC, meaning that we are the ones that are defining what are the knowledge gaps that we should focus on and we should make reports on. So again, it's a complete independent platform for conveying scientists, policymakers, and the public. We want to strengthen the Science Academies network in Europe and beyond. So the output that we are delivering are evidence-based policy reports that are validated by all the national academies. So by having this structure, we're reaching out to the expert scientists in the field in Europe, and also it's evaluated and validated by the national academies that is part of this. So this way, we think we also can manage to make timely, relevant, accessible, and actionable policy recommendations through these networks. These are some examples of recent reports that we have. This is just a very short glimpse of it. So Meat Alternatives that was launched in September 2025. We also have a report on artificial intelligence and health that started in 2024. It will be launched now in September. Security for sustainable energy supplies, very important topic for Europe. We also have a commentary on energy systems integrating. So the commentary are smaller than the full reports. Also, last year we launched the Changing Wildfires report. That was a very timely report also, which is one of the biggest challenges that we have in Europe at the moment. We have also a commentary on nature restoration regulation that was just released, and that was also very well received by the EU Commission. And also we have an IAP project led by the Cyprus Academy on threats to the Mediterranean marine ecosystem in a warming world. And that was based on a previous report we had on this A Sea of Change that was an ESAC report. So this is just some examples of the report we have. So ESAC and the European science policy ecosystem, how are we interconnected here? So we have a very tight collaboration with the Joint Research Center of the European Commission. We participate in the scientific advisory mechanism through the SAPEA consortium, so we're a partner there. And we also have very close collaboration with the European Commission and its Directorate Generals in those topics that are closely related to what ESAC is doing. So this is just also showing some pictures that we have recent meeting with EU Commissioners Roswell from the environment and Jørgensen for the energy and housing. The main project that we are working on at the moment is that we have a current project going on that I already mentioned, artificial intelligence in healthcare, together with FEAM, which will be launched in September. We're also working on ESAC as part of SAPEA Consortium is leading a work on guidelines for the use of artificial intelligence and science advice mechanisms. We're working on a report initiated by the European Commission on ultra-processed food, and also we are part of the work on European Democracy Shield. So we collaborate with other organizations and network like IIP, World Science Forum, SAPEA, and also the YASAS and FEAM. And I would just like to mention that we are trying to have a better connection or increase the connection with YASAS to reach out to experts in the younger academies also, because that's something we have started to do to get also that network into our reports. So then it comes to the topic that we were going to discuss today. So this is from then my role as the president of this academy network and also as a biologist. I see that artificial intelligence now is becoming part of the scientific method itself that we also heard in the introduction. So it's not just a post hoc analysis tool. And we see this shift is visible in the literature synthesis with also a hypothesis generation and emergent autonomous research systems. The next is that the key challenges are not only technical performance, but also based on trust, transparency, reproducibility, validation, and responsible use. So poorly documented models, hallucinated outputs, a lack of human oversight can introduce new risk into scientific workflows. I think this is important to take in. And I also think being part of a faculty member at the university, we see that the next generation of scientists will need hybrid skills. So deep domain expertise combined with data literacy, critical artificial intelligence literacy, ethical awareness, and the ability to collaborate across disciplines will be important. And also another aspect that we have been touching upon earlier today is that there's an important equality dimension into this. So the frontier AI models often require substantial computer, high quality data and specialized expertise. And without open tools, shared data set and accessible training opportunity, AI risks widening gaps between well-resourced and less resourced institutions. And that's something we already see. Okay. So then again, from my point of view, some examples that have come into the arena lately. There are a lot of examples, and Robert de Graaf gave an overview of the big questions earlier today. But I would just mention a few. So the advanced materials, which is the Google DeepMind's GNOME project, is one important. It predicted 2.2 million crystal structure, including approximately 380,000 stable materials added to the materials project. And this dramatically expands the research space for new materials of battery, energy, and electronics, which is a very important part of the energy situation that we are facing today. And another more recent example is MatterGen, which is a diffusion-based generative model that designs stable inorganic materials and can be fine-tuned for desired mechanical, electronic, and magnetic properties. And I think these cases illustrate the shift from screening known components to generating and prioritizing new candidate material. And this is also important when we're discussing the way forward in finding new materials for better energy solutions. Another very important topic has been from medicine and life science. The AlphaFold remains a landmark example, and this was also awarded the Nobel Prize in 2024 to Demis Hassabis and John Humper. So this was their paper in 2021. It demonstrated highly accurate protein structure prediction at scale. And then a couple of years later, it was the AlphaFold 3 extend this into modeling complex biomolecular interactions, protein, nucleic acid, and small molecules. And this has major implication for new drug discoveries. And as I'm also from University of Bergen, I'm part of the Bjerknes Center for Climate Research, and my colleagues there are using, have been long time working on models for weather forecast. And we also see that the climate and earth system science is advancing in this field. So recent work now shows that by using artificial intelligence can complement these traditional physical-based modeling. And the Aurora is the foundation model for the Earth system, trained over 1 million hours of geophysical data. So this can then perform strongly on tasks including air quality, ocean waves, tropical cyclone tracks, and high-resolution weather forecasting, being much more computational efficient than the traditional models. And then I think I'll end with the IA and the evolving scientific method. You were also mentioning this in your introduction, that artificial intelligence is beginning to support multiple stages of the research process, from literary synthesis and hypothesis generation to the experimental planning, analysis, and communication. And this is also, there is a Nature paper also on end-to-end automation of AI research, which demonstrates systems that can autonomously generate ideas, run experiments, write papers, and perform reviews. This does not necessarily replace scientists, but to change the skills required. So researchers increasingly need to work critical with AI-generated outputs. So I think this would be my background for the discussion today, and I think it's a lot of things that we can jump onto. Thank you.
Thank you. Thanks. Definitely quite some food for thought. And then we are going to get our second speaker, Professor Dominic.
Okay, so hello everybody. It's wonderful that I can be here today and to also introduce myself and show you what we are doing in my research lab. So I'm professor for machine learning and bioinformatics at the Technical University in Munich, but not directly in Munich. We are a little bit remote. We are at a new campus called TUM Campus Straubing for Biotechnology and Sustainability. And it's quite a wonderful campus because it's different than other campi. So we're approximately 150 kilometers away, close to the Bavarian Wood. So a rural area, a lot of agriculture is going on there, a lot of forestry, and we're interdisciplinary and transdisciplinary. So we have 25 professors, all of them in different fields, from social sciences over management sciences to natural scientists, material scientists, and also machine learning. And the question is, why do we need all of these different competencies in one campus? And we all know that our world is currently facing a lot of very interconnected and serious challenges, from climate change over loss of biodiversity, erosion of arable land. But it's not only environmental challenges that we are facing. They also affect our economies. They lead to social problems and also affect our health and our food systems. So what could be the solution? One solution could be, for example, that we get rid of fuel-based and fossil-based industries, and that we go towards bio-based solutions. So that's the field of bioeconomy. And here, machine learning can play an important role to enable the transition towards a bio-based industry. And that's what we are working in my group. So we develop machine learning models, statistical models, and also bioinformatics methods to enable this transition towards a circular-based bioeconomy. And in my group, we have three main research topics. The first one is about computational breeding and sustainable agriculture. The second one about computer-aided chemical and bioprocess engineering. And the third one is synthetic biology and computational biotechnology. And now I brought three examples how AI is helping us here and which models that we develop that help us to address some of the problems within these research pillars. So the first problem is sustainable agriculture. So the goal that we are trying to solve here is to get rid of pesticides or reducing the amount of pesticides that we're using by, for example, detecting weeds precisely in fields, for example, using drone technologies to fly over the fields to then develop AI-based weed application maps. So we would like to get a map exactly where you can find early weeds within the field to get the density distribution that in the end we can then use autonomous robots to remove these weeds either mechanically and site-specific or using technologies like spot spraying. Now the video hangs, like spot spraying to directly target the specific weed to reduce the number of pesticides that we use and that we go away from a uniform treatment of the fields to a more site-specific treatment. This saves, of course, resources and might lead to a more sustainable agriculture. And that's work that's mainly done by my junior group leader, Nikita, who is doing a lot of research in this direction. Another example is in the field of, and here is something wrong with the slides, it looks like, or it's the presentation, I don't know. But here we try to create more sustainable process plants in chemical engineering, for example. So the goal is here that we try to learn or train an AI agent that can more or less produce a chemical flow sheet that is more sustainable, leads to certain outputs without having any prior knowledge. And that is work that is done by Jonathan and my group. So we developed novel reinforcement learning methods that can learn through interactions with simulators how to design processes. For example, we have here a mixture of different chemical components, and we'd like to design a process that separates those chemical components into pure streams. But not only the purity is important, but also to do it sustainable, to use less energy, to produce less CO2. And we showed in some of our papers that agents are able to learn how this can be solved without having any prior knowledge in chemical engineering or in chemistry. And just through interactions with environments, we showed that the agent rediscovered principles in biochemical engineering that are at the master level niveau of our student. So that was quite surprising to our collaboration partners in chemical engineering. They said, okay, we have now something built that has the same level of a master's thesis student. So here AI comes really, or helps us to become a discovery partner to make sense of these huge design spaces and find good solutions there. And the last example is in the field of protein engineering. So here we try to develop AI methods that can introduce mutations in the protein to enhance specific functionalities, to make them, for example, to increase the activity or the thermostability of certain proteins, especially when lab experiments are costly. And here we are moving now away from just protein-based screenings where we introduce random mutations in the protein to AI systems that can propose to us their regions that might be very interesting to mutate and then to go to the lab to do less experiments. And that's all. So these were just 3 examples from the diverse research that we're doing in my group. And in bioeconomy, it's very important to have this AI technology because, and that's maybe important, bio-based solutions are not necessarily sustainable, but we can make them sustainable when we also integrate the issues of land use, of maybe modern slavery. And here AI can help us to find maybe better solutions to solve some of these problems. So thanks a lot.
Thank you. As an engineer and roboticist, I have a lot of questions, but I will refrain myself and introduce actually our third speaker, that is Maddalena, that she is online. Okay, in the meantime, I have a question. You might not be able to answer, but no, she can't hear us.
Hello, can you hear me?
So I will shoot my question in the meantime, and you keep the answer for later. You mentioned about simulation, because we have a lot of different scenarios and data, so you cannot do that with the real data or with the real system. We need simulators.
Thank you, Kirsten. Good morning, Francesco. Good morning to all. Thank you very much for this presentation. I cannot hear you, I'm sorry. And I cannot be there with you, as Francesco said, for problems with the flights. Today, I'm representing the European Materials Modeling Council. I coordinate a task group on application of AI for material discovery. And to give you some information about myself, my domain knowledge is materials engineering. I have a master in artificial intelligence with the Massachusetts Institute of Technology. And I'm the industry chair of a working group in materials for construction in the public-private partnership IMI, scientific coordinator for artificial intelligence at the Italian Association of Engineering Companies. And I'm also CEO of 3 companies. So a very busy person, but I'm very glad to be able to join you in remote today. As mentioned, it's important when speaking about artificial intelligence to dive into it with real applications. And this is the goal of the presentation today, to show you some developments we had in the company, DG Advanced, that I represent also today as CEO. In the presentation, you will see briefly what is it EMMC and what is it DGA. A glimpse to the AI background that is behind these applications, our concept, and of course the methodology that we followed using the different tools available within the world of artificial intelligence. Very briefly, the European Materials Modeling Council is an association constituted by more than 1,000 associate members, as you can see. The goal of the association is modeling the materials world, but in more simple way, to monitor, to roadmap, to be always up to date with the latest developments, also to interact with the European Commission to propose topics and subjects to be further developed during the work programs. We are full individual members as DGA, and we coordinate this task group on material discovery with AI within the focus area 1, advancement in modeling and characterization. As you can see, MMC is organized in 6 focus areas overall. And I would like to say today that you can join us anytime, just applying through our website. Okay, the open call for members is always there. DG Advanced, the company that is developing the application that I will be presenting today, is active in the automotive sector. Our main mission is to innovate the present materials and processes, because the automotive sector is a conservative sector, proposing advanced materials and also refurbished, re-engineered engineering processes. For this, it's very important artificial intelligence, as you will see. And reasoning about sustainability of manufacturing processes, it came up the idea to develop the architecture that I will illustrate you in the next slides. Before jumping into the concept, a brief introduction to the old lady artificial intelligence. because during presentations, I always like to point out that I totally disagree with the hype that is accompanying now artificial intelligence. Because AI is there, is an old lady, is there since a lot of time. You can see that it was born with statistics between the 40s and the 70s. And then, thanks to the computational power developed into the machine learning, deep learning, neural network, etc., between the 70s and the 2022. And all the hype came up in 2022 with generative AI, that it's not only large language models, and with the agentic AI. So machine learning is there since a lot of time. There are plenty of, sorry, I have my screen that is jumping up by itself. Is there since a lot of time, has very powerful tools, and the generative AI, from the industrial point of view, is a very good tool to support running developments in machine learning, as you will see during my presentation. So the application we developed use a hybrid system, use machine learning with the support of generative AI for the part of coding. Our concept. We have to propose to our clients sustainable processes, sustainable manufacturing processes. And during the plenty of European projects to which we participated, we saw always very interesting results about life cycle analysis. To measure, evaluate the environmental impact of a process, you collect through a life cycle inventory several data, and you calculate, according to standards, the impact categories of a process. Very beautiful, interesting results used to compare two processes, the old one and the new one, but that after the research, after the analysis, remain there and don't have a follow-up. We understood the potential behind life cycle analysis, but still we didn't exploit it. Up to we started using artificial intelligence to interpret the results. And it's what we did here. We understood, first of all, that artificial intelligence can help us to fill the gaps in life cycle inventory. It can help us to generate missing values, and it can help us to normalize in much faster way the data set. We can also use artificial intelligence to better extrapolate and infer information for the results of simulation of modeling. And of course, through artificial intelligence, we can also run in parallel way a life cycle analysis in a faster way for immediate fast screening of processes. On the basis of this, we started to investigate the world of artificial intelligence. And of course, we know that machine learning is divided in supervised model and unsupervised models. The unsupervised models are related to unlabeled data. And of course, they were the most interesting ones in our case, having to deal with the life cycle inventories, data sets, where there is not a well-known relation between the variables. So the typical case of unlabeled data. As you will see, for the moment, we explore the k-means algorithm, the basic one, but that already gave interesting results. First problem to solve, which data sets to use for the preliminary investigation. We went to a safe source, that is the European life cycle data sets, and we downloaded 99,000 processes, okay, huge amount of data. They were in a compacted form, Zolka format. Through the LLM, it was very immediate and fast to be able to extract from the metadata sets the data sets, to do all the exploratory data analysis with normalization, functional units, homogeneous, filling the gap of missing values. We could do everything in very, very quick way, and filter from the 99,000 files we had, 6,000 unique processes for materials. Among them, through a further filtration selection step, we reached the completion of the data sets for 91 processes related to metals and 42 processes related to coatings. For these processes and materials, we had quite complete homogeneous data sets with all the values we need to carry out life cycle analysis. We carry out the life cycle analysis, as you can see here, through a large language model. Also, it was very fast, very efficient. Here you have the results of the impact categories for 45 processes related to coatings. And in these slides, you have them for 91 processes related to metals. At this point, you see that you have 5 variables to study for many processes, so a relevant, a significant data set as a size. There are several algorithms that can be used in unsupervised learning. Here there is an overview, a classification with their main characteristics. And to start, we focus on the k-means because it's fast, it's simple to use, and doesn't require a lot of computational power. First step is a very powerful tool that we have in artificial intelligence is to carry out a dimensionality reduction. Because our main goal was, once we had the life cycle analysis of all these processes, to clusterize them, to categorize them, and group them according to their similarities. We know we have 91 life cycle analysis for processes related to metals. We know that for sure there are similarities among these processes. And with the proper tools and with the proper computational power, we are able to group them according to similar impact categories. And from there, infer important information about the feasibility of these processes. So this is what we did. We had 5 impact categories, and through principal component analysis, we reduced these 5 impact categories to only 2 fake variables that we called PC1 and PC2. Okay, so PC1 and PC2 are directly proportional in different ways to the 5 impact categories that you saw before. In particular, PC1 that you see in blue is directly proportional to high value of particulate matter and high value of human toxicity. And instead, PC2 that you see in orange is directly proportional to high value of water depletion. Next step was very easy through machine learning, through k-means, was to clusterize all these 91 processes related to metals in this chart, in which in the x-axis you can see the PC1, and in the y-axis you can see the PC2. And the informations that we started to extrapolate were extremely interesting from the industrial point of view, because you see that in the yellow square, you have all processes, all metals produced with processes with high value PC2. But high value of PC2 means high water depletion. So for us, that we are a designer engineer, we can give immediately a very important information to our clients. Don't invest in processes related to these technologies in areas where you have water scarcity, for example. Another very interesting information comes from the red square. The red square, where you can see you have processes with high value of PC1, high value of PC2. So it means they are extremely polluting processes, and where there are very strict standards about air quality, for example, okay, there you can forget to invest in this kind of technologies. As conclusion, you see that, of course, where there are this kind of requirements from the environmental point of view, for sure, the safer processes are the one in the green square. I conclude here. There will be much more to say. And as a key takeaways, I would like to, first of all, to say that let's forget about the hype since 2022 about generative AI, because there is a big word behind it. It is machine learning that, in our opinion, is much more powerful as a result. than large language models. And also, let's not forget that large language model is only a small branch of generative AI. There is much more that can be used in research, like diffusion model, like generative adversarial network, that are very interesting for material design. Second, the right approach is not, I want to use AI because I have to use AI, is which problem I'm not able to solve in this moment and how AI can contribute to help me to solve them faster. And at the end, always very important, AI is based on statistic. Doesn't give correct answer, but the most probable correct answer. Thank you for your attention. I don't hear you, and I hope you could follow me.
Thank you. Thank you very much, Maddalena. And we are launching a new master program in advanced material, so we hope to have the chance to invite you on campus in the future, as you couldn't make it this time. So in the meantime, then we have Rishamit. So I can finish my question that was stopped before. So with all this simulation, okay, I can continue. How reliable are? I mean, I always say to my students, of course, before you get into the lab, you need to do simulation. And that is a propedeutic step in robotics. In many cases, in machine learning, it's not even a propedeutic step, it's a necessary step because you don't have the data, you need to simulate data and so on. So how can we assure that the simulation environment is actually giving us any meaningful reply?
You don't have my slides? I don't know why. I can share it quickly with you if you want me. Yeah, maybe I'll come there.
Yeah, you're right. So simulations, it's all also about quality. So in this process engineering field, so what we created is shortcut simulators for specific chemical apparatus, where we have the physics, where we know everything, how it works in a distillation column, for example, or in a mixer. So we get accurate results with this. So they might not converge always, but we also integrate it into our learning pipelines to handle problems where the simulators don't converge, for example. But yes, you're right, if the simulators don't work and they bullshit in, bullshit out more or less, then you can't learn anything. But there is also a big problem in general when we do this type of learning that all the algorithms that exist so far, like AlphaFold, are not designed to solve such complex combinatorial optimization problems. That's why we developed a new type of machine learning technique that we call self-improvement learning. And this is that the agent generates their own data, even though it is crap in the beginning. We evaluate it with an objective function or a surrogate model. And then we take the best solutions, we imitate on the best solutions, and then we could also mathematically prove that this leads to a self-improving loop when we do this several times. And with this, the agent generates their own data and gets better over time.
Thank you. And then I have a question for Liz. You mentioned earlier that AI is speeding up the process, but it's not only that. So using AI and machine learning is not only getting things done a little bit faster, but you say it's changing the paradigm of how we do science. Can you elaborate a little bit more on that?
I mean, when you're using AI, you're generating data based on what's already out there, and you need it's narrowing in the way the science is going. And when I talked about this, I have this. It was a paper that I came over that I call it the paradox paper. It says artificial intelligence tool expounds scientist impact, but contract science focus. So this also shows that, I mean, those that are using artificial intelligence are publishing more, they are more productive, they are promoted earlier, get positions, etc. But they're also narrowing in the field, the scope, the fields that we are studying. And that makes something with the whole scientific community and also the way we're working and the way we want to work in the future. So I think this is important things to grasp. I mean, just by listening to you and also the presentation that was given, it's super powerful tool. It's so important to add all this extra knowledge into it, and we can access so much data in very short time, but it's also how to use it and also how to extract the good thing from it and also balance the output of that. And I think that's something we need to keep in mind.
Thank you. Then do we have a question from the floor for our panelists? On the back. Can someone help us with the microphone, please? Let's get the question first. And then...
Hi, I enjoyed listening to all the panelists. My name is Dr. Yalanupoya. I'm a chemist. I come from the Pacific Islands, Papua New Guinea. I currently work in the United States as a chemistry professor. Now, my question is very simple. Do you think AI will replace those of us who work in labs?
No, I don't think so. Maybe we have to change our ways how we work in the labs, but I think we have to go into a symbiosis with the AI. So maybe with an analogy with doctors that do MRI image analysis. So there might be a medical doctor who is using AI and he will survive more or less. And I think it's the same in science. We have to use it as a tool. It will not replace us, but we have to be creative to find new ways of how we can interact with the AI. That's at least my opinion.
I agree. I mean, I think the AI will, of course, make much more lab work not necessary because you can do it by using AI tools. So, but still, it's something in how you evaluate the process. I mean, it's not just the results; it's also some of the process along the line that's important. From my personal point of view, I see the challenge with the new tools and the new techniques. It's improving a lot on the data quality. As an ecologist, I'm still happy I've been spending 25 years field working in the Arctic, and I've seen the changes along these 25 years. And that's a field where I feel very confident when I'm bringing students into the field and showing what's going on. And I think that's something that you cannot get on artificial intelligence, that competence. And I think there is also some examples from lab work where that also will be necessary in the future. But of course, it will be so, it will redundant a lot of the work that we're doing at the moment, I think. But I hope it will not be totally replaced.
Thank you. And now the floor is for Rashmit.
Thank you. Thank you so much. So I'm Rishamjeet Kaur. I work at Central Scientific Instrument Organization. It's one of the CSIR labs located in northern region of India. Located in northern region of India. This is like my beautiful campus where I work on development of knowledge representations, LLM and AI for low resource languages and low resource domains. So, here we are talking about AI accelerating discovery. So the key word that I'm going to pick up here is acceleration, right? Which means AI moving faster on the problems that we know how to study, like faster material screening, more accurate climate models, maybe better drug targets. While that is real, that is happening, there are a lot of domains where such kind of knowledge is not formalized. There is no knowledge pipeline that exists. The data, the benchmarks, they do not exist. And a lot of this is scattered in the intuitions of expert or or traditional practices, local knowledge. And this is where we work, this is where we build. So I'll start with first example. I'll show you 2 examples. So the first one, where we built agri advisory systems. So let's say when a farmer in Punjab picks up a phone call and ask, is it going to rain today? Should I irrigate or wait? Well, he won't speak English. He will be talking in Punjabi, something like Aaj barish hoegi ya nahi, but just for the audience. So it seems like a very simple question, right? Like, go check Google, AccuWeather, find out what's the big deal. But no, the answer is not that simple. Answering this question requires information about his crop, the growth stage, the weather forecast, his location, the soil type. It requires judgment of a meteorologist as well as an agriculture expert. That too available when he wants to know, on his demand and in his language. So, but like this information exists, like this expertise exists. It exists in the minds of expert, or it is scattered across so many different sources. It is scattered across package of practices, books, publications, everywhere, right? So what we do is we build that knowledge layer. We build that knowledge layer where we try to capture the traditional practices, where we try to capture the modern scientific knowledge. And we build knowledge representations. Like one such example is knowledge graph, where the nodes are represented by certain agriculture entities and the relationships are defined between them. When we combine such kind of, like the precision of such kind of symbolic knowledge with the generative power of large language models, it actually helps us to generate responses which are much more accurate, which are grounded in facts and not hallucinated. So just very quickly to give you the idea of the whole stack that we work on different applications like education, agriculture, food. We work on models, fine-tuned models, prompting. We work on a big part of our effort goes on generation of data sets, raw data sets, synthetic data sets, instruction fine-tuned data sets, knowledge representations. Then we build tools for cleaning those data sets, annotations of those data sets, quality checking. And we intend to make, like we keep on doing that, everything publicly available. So we can have sort of like, the AI public infrastructure, which can be used by the community, which can be used and leveraged by everyone to build on top of it. So coming to the second example, which I want to show you. There is a concept of nutritional dark matter. Like, plants, they have such chemical diversity with more than 3,000 phytochemicals, but we know hardly 85% of them and their relationship with their diseases. So we thought, okay, let us look at a certain category of herbs and spices, maybe because, I don't know, because they're traditionally and culturally, they are known to be related to the, for disease cure, or maybe because an Indian, my love for spices, we did this, I don't know. So we ended up building one of the largest database for spices, herbs, the phytochemicals, the diseases, which was scattered across, again, various sources in the handbooks, in the different databases. And we attempt to see, like, and we build like a unified representation. What the geometry of graph tells us that the science doesn't know, or something that we already do not know. So we wanted to see, can we like rediscover existing knowledge, something that we already know, and also generate new hypotheses. So I will not go into any technical details, but we ended up building algorithms and scores, which tells us how strongly a certain phytochemical and diseases, they are correlated. And then we tested it against the standard databases. We found that out of, let's say, that some certain top number of associations between phytochemical and diseases, the 40% was something that we already knew, like something that we rediscovered from the existing knowledge. 20% were something which were part of the like high confidence, because they knew through the genetic pathways. 40% were completely new hypotheses that could be tested experimentally in the lab by the other scientists. So out of thousands and thousands of associations, we narrowed it down to the few high confidence hypotheses that could be tested. And it helped us to distill the novel scientific information from the traditional knowledge of herbs and spices. And all of this was possible not just for the model and the compute. I mean, of course, that is required. And many times in low and middle income countries, sources in countries, those that is in itself is a challenge. But a lot of this was possible because somebody had to sit to create the databases, to create that knowledge base. And this is not really a technical problem. This is a resourcing problem. And when we talk about AI accelerating discovery globally, we also need to think about domains where such kind of knowledge has yet not been captured. And we need to ask ourselves, like, whether, like, which science is really worth capturing, what is it that we want to do, and for whom we are doing this, and how it really impacts billions of people. Thank you. Thank you.
Thank you. We also have an answer from Maddalena about the previous question on AI replacing people. And she mentioned Ford has already called back 300 engineers for online quality control since AI couldn't grant the same results. So it's a fear the press is sending around is more speculative than fact-based. But in my opinion, maybe I want to be a little bit more provocative. Maybe it's a good thing that people are replaced by AI, and maybe those people can do something else. So if we think about the Industrial Revolution, there were people saying the machine are replacing people, and there were people destroying the machine. There was a full movement of people destroying the machine in the Industrial Revolution, the Luddism. But I don't think anyone in the room would want to live in the pre-Industrial Revolution, right? Anyone wants to live before the Industrial Revolution? I mean, we wouldn't have this conference. So maybe it's good that those people can do something else and create something different that doesn't exist yet. What do you think?
Well, I would definitely like to, all the repetitive manual tasks that we do, I would definitely like machines to replace us. But I don't think they are doing all the work. They can do all the work and they can actually replace us. We'll have to definitely reskill, upskill ourselves. We have to understand how to work with AI and what are the tools that we can use to make our life easier. But I really do not see like replacing them anytime soon.
Difficult question. I think we should not think of letting the AI replace us. So currently the stuff AI is doing the stuff that is fun for us, creating images, doing art, whatever, writing. So writing not always fun, but it can be fun. But maybe when we think about it, of course we can let the AI do all of the things for us, but maybe it's better if we interact with the AI to have support with it and don't let the AI completely replace us. I think that's the way that we have to find, because I think also that there is a danger when we let the AI do everything for us, we will also lose competencies a lot. And that we already see with coding and other things, that students lose competencies because they just let the AI code and they don't understand the things anymore. So we still have to teach the competencies to also understand what the AI is doing.
I think you answered it quite well. Of course, it's nice if we can have AI to do things that is repetitive and etc. And I don't agree that everybody will be replaced, and especially again with the what I'm afraid of losing is this scientific engagement and the discussions that you have between people. So you need to have a certain volume of people working on things, because you have the challenge of isolation with use of AI, more and more use of AI. Again, from being in remote field work, when you don't have access to ask co-pilot or whatever, you see that you're starting to have much more discussion again, because you can't just ask for the right for the answer. So you need to start discuss again on which should we do this or that. So I think it needs to be a nice balance. But of course you can have good benefits, but I think you can't replace it completely.
Thank you. We have questions from the public, quite a lot actually.
Oh, okay. Shall I start here? Hi, my name is Rita Okorafor, Texas A&M University. I'm a petroleum engineer and I apply a lot of AI to my work. I also do lab work. I do numerical simulations and things like that. I want to say never say never. And it might be a challenge to all of you on the panel, but that is what I truly believe. Because let's look at what we've heard so far from all the panelists. We've heard about hypothesis discovery. And then in the lab, what do? We're picking up tubes, pouring liquid, checking the result, measuring it in equipment, collecting these results, analyzing them. etc. All of us here know the workflows. If you are able to put something in a logical pattern, it means you can tell a machine to do it. So basically, I say that even before the next 10 years, we're going to see AI or machines, robots, replacing most of these things we do in the lab physically. I own a lab. I don't step into my lab. I give my students the instructions. So that means if I can put those instructions into a machine, the machine can replicate it. I think that's just the perception that I want to say, that let's not say it's impossible. It's possible, but there are things that we will still need humans for. And I think I like what you said, like we collaborating with using the systems to try to advance or accelerate knowledge. Thank you.
Thanks. Yes, let's collect a few questions.
I do the first 4.
So following up on the point that Francesca raised, in software development, the coding at the end, that's the easy part. Understanding what the problem is the hard one. With that in mind, and all these AI systems coming up, should we use the opportunity to refocus on what we teach and what is it that we should teach for the future?
I do those 2 and then the next round. Yeah.
Thank you. Following up on the teaching, maybe I should stand up. Following up on the teaching and on the spirit of accelerating discovery, I'm wondering about the prompting engineering or prompt engineering. No? We need to have a good prompt in order to get the most out of the AI. But in order to build and engineer a good prompt, we need critical thinking. And to build critical thinking, we need good teaching. And we need to train those students. And we need to maybe have a step back and, to promote science and discovery and technology, we need to train these students. So I wanted to have your input or your opinion on how AI should empower education in order to then accelerate what we are discussing here. Thank you.
Hello, I'm Morita from Indonesia, and I'm working in health. And in medicine, there's already high concern that AI will replace doctors. And even in China, they start to have hospital with robot that can treat 3,000 patients every day without feeling tired, and they will not ask for higher salary, things like that. So it's a very big concern in health. And now our team is developing a AI to read chest X-ray with machine learning. That, of course, with the consent of radiologists there, that the AI can replace them. And we found the problem also with black box of machine learning. And how do we solve that problem? And because when we use this machine learning, we get higher predictive result than if we use more interpretable method. So how do we keep balance in it? Is it better to have a higher result, but it's not really interpretable, or have a lower one, but more interpretable one? Thank you.
Very interesting questions. I would kindly ask the panel to pick maybe 1 or 2 maximum each, so that not everybody replies to every question.
Okay, maybe I reply to the teaching one. It's a very important topic that we now teach competences a lot, but also how to use the AI tools. So, for example, I'm currently creating a new course where we do AI-assisted coding, that we teach the students how to use the AI, but not just using the AI, but really understanding what the AI also generates. So that's the most important part, that in the end, they can explain what they developed, which competencies they developed. Even though maybe they start from scratch, they are chemists, have never done programming. We try to teach them how to use the AI, and in symbiosis then also understand, for example, what is a model view controller and stuff like this, so that it's more interactive, and also that the AIs are used as teacher, and that they also go back then to publications to also verify their findings. So that's what we try to do. Let's see how it goes. But I think it's important for the future that the students learn how to use the tools effectively.
I mean, I don't think I can answer the technical questions here, but I would also say a little bit, I mean, again, on the teaching, I think this is, we see that it's, especially me being in the university for quite some time, there is a change. There's a new generation of students coming now. So one thing is what you teach and the topics to teach now, but I see that it's a whole new way of evaluating the thesis and the research by students at the moment. And this is, so now they have to say what tools they have been using. And then it's me to decide whether this is, how shall I grade it? How shall I evaluate the output at the end? So I think this is parallel things that needs to run in future. So it's teaching the new generation, but it's also how to evaluate it. I have colleagues that is kind of not accepting the student at all to use artificial intelligence in their thesis, etc. I think it is part of the way we're moving on, and it's part of what they will meet in the society out there. So I think it needs to be part of it, but I find it challenging to know how to evaluate their own knowledge and how they just used a tool, etc. So this is something that I think it needs to be focused on in the time to come. And to your, I couldn't answer your question at all. I'm sorry, it's not my field of competence.
Am I audible? Okay, maybe I'll try to answer the question of problem framing. You have very rightly put that, right now, let's say the Claude code, they can do so much of programming that we no longer need to even learn how to code. Like I used to code a lot, but now it's been, I think, months. I have not done that. I just prompt. In fact, I have started forgetting the syntax of Python, which is not a great thing, but what to do? There is no need for me. So, but what is really important is I need to know what is that I want to build. What are the constraints? Which models should I use? And I think this is something that we really need to teach to our kids. Like I tell my students to, I need this. They just go to the Claude. I know that they are going to use the Claude for the coding, and this is perfectly okay. But many times they don't even know what to ask. So framing the problem, what are the constraints, which models to use, which models are capable of reasoning ability, coding ability, all these things, they have become very important. And I think, in fact, for all scientists, for researchers, and for the next training itself, I believe everybody should be now, have some sort of AI literacy. By that, I do not mean you need to understand the different architectures, or you need to understand how the neural network exactly work, or what the backpropagation algorithms are, but how to use the AI. What are agents? We are moving now in a very different direction. Now with this agentic coding, and maybe you may have heard about OpenClaw and everything, the concept of loop engineering coming up, where the whole software pipeline is getting automated, right? Like they tell what they want to build, the product specifications, and maybe the benchmark data set against to measure the performance. And it can iteratively build the software, test it, improve it till it matches your requirements. So these things are happening, and as a result, there are the companies are not hiring at least the freshers, because a lot of dirty job which earlier the beginners used to do, they can. But it doesn't mean that we don't need to teach AI, or we need to be scared of AI. So teaching AI literacy, computational tools has become very important at this age, I believe, and for everyone, doesn't matter what the field is. And now coming to Rita's question, Rita, what you just described, using, the robotics and everything, it's like now being called self-driving labs, right? And it has started coming up. though in a very specific industrial scenarios and highly funded, I would say, academic scenarios, not everywhere, but there are now robotics, then the instruments, and then the AI on top of it, where they are designing, conducting experiments. But however, of course, I mean, it will take some time. And this specific part, I feel it will definitely create more divide, because getting the infrastructure, that's a big challenge, especially for the low and middle income countries. But I feel it will take time. It is not that simple of a problem. The reason being that, every instrument, it has like manufacturers, they use their own standards. So communication between one equipment to the other and to the AI, it is still a challenging task. So we will see many open source software and hardware tools coming up that will help in this direction. But in coming years, I definitely see a possibility. But I think this is also a good thing in a way. There will be more accurate experiments. Students, they make mistakes all the time. Sometimes I just don't trust the results when they come up with 0.99 correlation. Like, I don't trust them. This is not so. So this will definitely bring in accuracy, and it would also require reskilling of the everybody in maybe how to do the communication protocols of between these equipments, or of basics of robotics or AI. Yeah, thank you.
Good, let's do another quick round of questions. Or
I just have one comment, maybe also to the medical domain.
Very quick.
I think what we still need is domain knowledge, and it's the same for software development or for the medical domain or for other domains. If we don't have the domain knowledge, we also can't judge what's coming out. And I think that's getting even more severe when we think about biology, because in biology, we have a lot of dependencies in our data. They are hidden, latent dependencies. And if we don't have the domain expertise, we can't identify them. And then we get a lot of machine learning models that produce maybe good predictions on our testing data, but if we get it out in the development phase, they completely fail. And there are a lot of papers right now, also published in Nature and so on, that show that a lot of the systems fail, and that we also can hijack a lot of the systems. And if we don't have the domain knowledge, we can't judge this. So it's very important that we keep this domain knowledge.
Okay, hi, good afternoon, everyone. My name is Imelda Chukwu, and I work with the Nigerian Institute of Medical Research. So for me, all this talk about AI and if it's going to replace our jobs got me thinking about the experience I had coming here. So I booked my flight almost, and I got a call from a customer care telling me, oh, you don't have a luggage attached to your flight. And I got to know much later that I wasn't even talking to a human being, but an AI. But it was so realistic, I could have sworn I was talking to a human being. We had back and forth. So what we're saying is that the AIs are now well-trained and optimized to sound like humans, have a real discussion. So I believe this is happening. It's already here. They are going to somehow replace our jobs, if not 50% of the jobs. So the question is, are we ready for it yet? And are we looking at how do we regulate this AI when it happens, and what is the ethics around that? Because unfortunately for me, the AI gave me a false information, which led to me missing my flight, and I had to pay for a more expensive flight. But I had to go back to them and ask. I didn't know I was talking to an AI, so I felt violated, because it should have said, oh, you're talking to a virtual assistant, but it didn't say that. So I said, what are the ethics behind this? Am I not supposed to know I'm talking to an AI and all that? So it got me thinking, what are we doing? Are we prepared for this? What exactly would happen when we get to that stage where AI is doing everything? Then how do we make sure we are protected? Thank you.
Nice, it's a new Turing test.
Hi, this is Pooja from India. I also work in CSIR. So I'm a material scientist. From a material perspective, I have a question. Like, now AI is affecting every field. Everyone has to learn this domain. So most of the discoveries, if you see in the material space, are by the serendipity. So AI is more towards, optimization, tuning, refining. So would this cut down the kind of discoveries, especially in the material space? Second question in this similar area is, most of the models which are built for the material discovery are based on the database quality. but we don't we are not yet ready with the database quality for each and every class of the material which we are trying to optimize or come up with the best composition. Also, cleaning of the database, ensuring the database is correct. So that's also a big challenge. So how in the material space this can actually make an impact, or what could be done?
I think we have one more from Emilia.
Yes, let's take Emilia's question and then we do a final round on answers.
Sorry. Thank you so much. So Emilia from Slovenia. I don't think AI will take our jobs. I'm sure that you're all reading newspapers, and just this week there was a news that Ford is hiring the people they fired, the engineers they fired. More than 1,000 engineers. Why? Simply because AI was not delivering. Another thing, AI is costly. It costs a lot. So we're speaking like we have funds that we can spend for, I don't know how much, we don't have them. And it's not only the economic cost, it's the environment cost as well. AI needs electricity, AI needs water, and so on and so on. So AI will definitely don't take our jobs. But we need to consider when, like I liked the symbiosis, I took that down, how to live with AI so that the planet will be still here and we are going to still be here. So please not think that AI will take our jobs. It won't.
If I would be the AI on the panel, I would say, let's see. Let's meet in 10 years. But I'm not the AI, so I would just leave the answer to our panel.
Sorry, there were too many questions. I think I even lost my thought. So maybe the first that where we were talking about chatbots and assistants, right? And where she felt cheated. I feel you. The same has happened with me. And but still the tone was very monotonous, with the AI speaking, so I could figure this out. I think when you were talking about regulations, the EU AI Act, that's very much says the very similar thing. It characterizes like it has a risk-based classification system, and it puts the chatbot into a, I think, limited classification system where you can use it, but you need to inform the users that they're interacting with the chatbot. So I do understand that there should have been, and maybe that's where such kind of regulations which are built, they will help. They are there so that people like us, we don't feel cheated, that we don't even know we were talking to AI. So I think the regulations, the governance part can take care of it to some extent. I think everybody has been making sort of the same point that AI is here to stay, and we need to learn how to live with it. And one thing which I would like to highlight on the same lines as a job fair. Even I don't think that the jobs will be, it will completely replace us. There will be less jobs, but I feel that with time, our technical expertise has more value, because AI generates such plausible sounding answers that we need that technical knowledge to understand when it is just BS. We need that BS filter inbuilt in us now, and that's only the domain knowledge, technical knowledge that can give us. So the domain knowledge, the technical expertise that people have it has become more important than ever, I feel, in such kind of cases. Would you like to add something?
Maybe also just a few positive words. I think we should think positively and should not be afraid of AI replacing us. We should see the potential but also the danger. And I think the danger lies in the environmental impact that AI is generating, and that's huge. And also when we currently look at the big companies, they're all struggling financing all their servers because of all the simple requests that we currently have for the AI system. So if this grows and if this should really replace everything, then this would not be feasible currently, I think, with the energy that we have on Earth. And their environment is more important than having AI everywhere.
Okay, so I will also end with some positive reflections from my side again. So I think, yes, it is costly to use the AI, but it's also saving a lot of ecosystem because I do a lot of smart sampling now, so we are testing a lot of use of drones for sampling and not making big footsteps in the Arctic and vulnerable areas. Cruises are super expensive, very polluting. So if you can use autonomic vehicles and autonomic monitoring stations like that, that would also add a lot of new data and also move it forward. So again, it's actually giving us more data, more things to work on. So that's also a good thing. And also with, as I've been working a lot on the deep ocean, and I'm so fascinated by the ecosystems that you have far away from the sun-driven ecosystems that we have on land. And I'm also from Norway, and I'm afraid of the hunting for deep sea minerals. And so I'm also happy to see we don't need the minerals. We can actually be reusing what we have, using our circular economy. So it's new ways of thinking, it's new solutions to the problem. So I think it's a lot of good things coming out of that. But we also are in a time which is that we haven't touched upon earlier, but it's challenging time at the moment. And I'm working in the Arctic, and the geopolitics is also getting quite challenging with this sharing of data that we were supposed to. I mean, all this data that we need to share it, we need to make sure that everyone benefits from it. But now we are in a situation where we have it should be as open as possible, but as close as necessary. So that's another issue that is we haven't touched upon. But I think the AI is here to stay, and I don't think we will run out of things to do. It's still going to keep us busy for many years.
Thank you, fantastic closing. So we actually know more about the moon surface than we know about the depth of our own oceans in our own planet. This is another great example of how natural science and engineering actually work together and can work together. So a round of applause for our panelists. And we are taking a short picture as usual, but don't leave because I have a couple of announcements to make.
Thank you so much.
We can clap for you at the back. We can clap it for you at the back.
Perfect. So it doesn't break. Okay.
Great. And so now it's time for a coffee break. And important information, the editor-in-chief of Cell Patterns has arrived and is going to be available during the coffee break now. It's going to be available also after the research talks, between the research talks and the EC pitches. And it's going to be available as well tomorrow morning before the session starts from 8:30 to 9, and the first coffee break in the morning. So take the chance and pitch your idea, get some feedback on your potential publications with him. He's been very kind to come for us. And then about the gala dinner, so the easy pitches should finish around 7-ish. So ideally, we would like to leave and walk together to the restaurant. It's about 20 minutes walk, 15, 20 minutes, depending on where we start on campus. So around 7:15, we will probably start leaving from here, moving towards the east of the campus. If you want to go back to either Krupp or Mercator, wherever is your accommodation is fine. You don't have to come back, but make sure that you catch us because we're going to go towards the exit that is on the east side. So we're going to pass through Krupp and Mercator, but keep an eye.